Hello, everyone. Welcome to GeoTalks 2025. I'm Jessica, the Marketing Manager here at Blue Marble Geographics.
Good morning, everyone. I am Meg. I am a marketing content specialist here at Blue Marble Geographics and a host of the GeoTalks podcast.
We're excited to welcome all of the geospatial technology enthusiasts who have joined us at the 2025 GeoTalks User Conference. The insight-driven sessions we have planned for you will help explore our users how they utilize Global Mapper and Geographic Calculator in projects around the world. To get started, Patrick Cunningham has overseen the growth of Blue Marble Geographics over the last 20 plus years. Today, Patrick is kicking off GeoTalks with his insights on our GIS software and what's on the horizon for Blue Marble Geographics in 2025.
Good morning, good afternoon, good evening. Welcome from wherever you are attending GeoTalks with us this year. My name is Patrick Cunningham. I'm the CEO and President of Blue Marble Geographics. Very excited to kick off another Blue Marble GeoTalks as I get to do every year. It's something that we take a lot of pride in here at Blue Marble, and we've kind of mixed things up this year. So there's going to be a lot of new kind of features to today's presentations, and I hope that you'll find it as interesting and enticing as always. We're going to have a mixture of presentations from our product managers, our technical experts, and our customers and users who have their use cases, their examples of what they do with the software to share with you. That combination we feel is hopefully going to provide a lot of value and education to you today. I don't know what different interactive components we're going to have in store for you this year, but I encourage you to take notes, queue up some questions, and we certainly will follow up on everything. But we've got a great group of presenters today for you, so I hope that you're excited, and I hope you find a lot of value in this. Looking back on 2024, we had a lot of exciting releases and accomplishments, and I hope that you all have had a chance to start to dive into the new features and tools. It seems like we're always releasing something new, and I'm not trying to brag, but it's I wonder, do all of our users, are they aware of this, these great tools that we've been adding, and have they had a chance to dive into them? About this time last year, in the minor release of Global Mapper 25.1, we released a solar shadow analysis tool, actually. And that's a really great feature. It has a lot of different uses in Global Mapper. I would encourage you to check that out. We've done a lot around our scripting tools and interfaces and support for Python. This year, we also released a self-guided training portion of our website. And so now we have some self-guided courses available that are available to you. Many are free. Some of the more intense ones, there's a little small fee. But these are great ways to keep up on all the new features and technology changes that we do every year. Really major things we did this year, we released Geographic Calculator Cloud. So this is a real great first step for us towards getting some real powerful tools out there in the cloud available for our customers. We've had some cloud offerings in the past. We even had a version of the GeoCalc libraries as a repository available for a number of years, but this is the first kind of iteration of some of the desktop tools from Calculator that are now available in our cloud offering. It's freely available right now to current users of Geographic Calculator Desktop, and that's just the first version of the Geographic Calculator Cloud. We've got a lot planned in store for that, and just maybe that might lead into some other cloud offerings around some of our other products, like Global Mapper. We're certainly starting to scope those things out. So stay tuned for all of that. It's going to be really exciting. Not putting any dates around that, but it's definitely on our radar. The other major thing we did this past year in 2024 is we released our Insight and Learning Engine to Global Mapper Pro. This is in beta version, so it's available free as part of Global Mapper Pro. And this is a module focused on deep learning tools that allow you to work with land classification, building detection, and even vehicle detection. This is an expansion of a focus that we've had around machine learning. We've had tools now for a couple of years around semantic segmentation, where you can work and train the tool on a point cloud to find objects in a point cloud, which is a very powerful tool that's in Global Mapper Pro. The Insight and Learning Engine introduces deep learning modules and algorithms available to train and teach the software to work with your data. Just a lot of great new areas that we're getting into with the products, and I'm sure that our technologists, our product managers today will be hitting on a lot of that with you. I would be remiss if I didn't point out that we also are very much focused on the pixels to points or drone and UAV data processing tool set we have in Pro. We've done a lot on that in 2024 around enhancing the quality of the output and the processing time for the output. Look for more feature sets around those tools this year in 2025. And before I hand it off, I understand that Mackenzie is going to be following me up. She's going to be sharing with you some of the latest in Global Mapper Mobile. And we're not putting that tool down either. We definitely be working on more feature sets for Global Mapper Mobile. Working on features like I've talked about, or working on more customer-driven development. And that's always a theme that we go back to time and time again. So, supporting any and all file formats that we can. So if we're not supporting the format you need, just let us know. We'll get it on the list. Enhancing features or tools that you use when you find something missing, whether it's something in contour analysis or line of sight. We believe in customer-driven development because you guys are the experts. You're the scientists, the technologists, the surveyors, the software developers that know, your areas the best, and we just provide the software and the tool to help you be successful. So I believe we have a new beta area of our website. We'd love you to join up and be a beta tester. And then if you did not get a chance to submit a talk for GeoTalks this year, please stay up with us and submit something for next year because we'd love to hear from you. So thank you very much and enjoy the rest of the day.
All right, well, good morning, everyone, and welcome to GeoTalks. Patrick gave a very nice introduction there. My name is Mackenzie Mills, and I'm the next presenter here, and I'm from Blue Marble Geographics. I am a product manager, and I work primarily on the Global Mapper desktop and Global Mapper mobile programs. So today, I will be going over Global Mapper Mobile, sort of what is this mobile app? It's available on iOS and Android, and how might it be used in the field in a workflow, and how might it be relevant to your work. So hopefully you'll learn a little bit about Global Mapper Mobile, and if you haven't already tried out the app, pique your interest and try it out. So I'll dive right in here. We're talking about Global Mapper Mobile. Now, Global Mapper Desktop is probably the most known program from Blue Marble Geographics here. And Global Mapper Mobile is an extension of that for field work. It allows you to take map data that you've prepared or done some analysis on in Global Mapper Desktop into the field on a mobile device, a smartphone, or a tablet. As I mentioned, Global Mapper Mobile is available on iOS and Android operating systems. So you're able to sort of have that map data, that GIS data in your pocket, pull it out in the field, see your location on the map, look at vector, raster, and elevation data, and use it for reference or adding data to your map. Global Mapper Mobile is actually a free download from the app stores, the iOS App Store and the Google Play Store. That free version of the app gets you loading data, creating some data using the GPS internal location services of your phone, and some other great features. So I'll just run down a short list of those here. As I mentioned, you can load raster data, vector data, and elevation display. With the free version of Global Mapper Mobile, data is loaded from a proprietary Global Mapper Mobile package format, and that's something that you can create and export from the Global Mapper desktop application. So you can use all your own data. It's very data-driven, just like Global Mapper Desktop. That Global Mapper Mobile package format efficiently packages up all of those data types and allows you to view them all together on your mobile device. And you also have the ability to open a control center and toggle layers on and off, just like you would in Global Mapper Desktop. The free version of the app uses the internal location services of your mobile device to display your GPS location. And you can also use that location to create features on the map. So you're able to create point, line, and polygon features with a variety of methods, whether that's using your finger to tap at a specific place on the map or draw a line, or again, using that GPS location, which is probably more common when you're collecting data in the field, where you tap the screen and it's dropping a vertex or a point feature at that GPS location wherever it is on the map. You can edit existing vector features, those that were created in Global Mapper Desktop or imported from another file there. You can view those attributes, edit those attributes, add information, and you can do the same for vector features that are created in the field in the mobile app as well. Additionally, you're able to view those attributes, you can record new attributes, and we have some longer form feature notation areas where you can add longer form notes on a particular feature in the field and even record an audio note and attach that to the vector feature, have that export with your map so you can share a little bit more detail easily that way. Another way to collect data in Global Mapper Mobile is with some images. You're in the field, you have a smart device, a tablet or a smartphone that has a camera, so why not utilize that, snap a picture of something in the field. You can add that as an attribute to a feature, an existing or one that you've just created in the field, or create a specific picture point type feature, which is essentially a point feature that primarily holds that image and it will appear on the map at the location of that image. All those images and audio notes can be packaged up with the map and shared to other Global Mapper mobile users or back to the Global Mapper desktop, where you can open that data and perform further analysis and utilize it however needed. Lastly, with the free version of the app, you can stream in some online data. You can stream some OpenStreetMap data. That is our free source provided with the free version of the app. It provides just a global reference, getting a little bit of reference data of local features into your map so that you can view your location in that context or start creating features with a little bit more information. Now, there is a subscription version of the app, and that would be an add-on. Once you download the free app, you can register the pro version. We're following sort of the same standard and pro levels that we have with the desktop app. And that pro version of the app, for a yearly subscription at a nominal fee, unlocks some additional features that can really enhance the data collection and use of the app in the field. So the biggest feature with the pro version of the app is probably the ability to connect to external GNSS units via Bluetooth or a TCP port connection. And that, of course, increases the accuracy of the data that you're collecting with a GPS signal. You can also apply RTK corrections. Global Mapper Mobile Pro has a built-in Ntrip client where you can log into a known RTK correction source, apply those corrections to the data that is being collected from that external GNSS device to create, really very accurate data that you're collecting and creating in the field all through this mobile app. Pro also unlocks simultaneous feature creation, so you can be recording a track log and dropping points of interest along that track, so creating multiple features as you're going along there. And then we've got some analysis tools in the mobile app as well. There's sort of light versions of analysis that's available in Global Mapper Desktop. We've got viewshed creation for sort of a line of sight analysis, volume calculation based on loaded terrain and a closed polygon feature, and then contour line creation. So just creating a derivative of the loaded terrain that you have maybe in your map, allowing you to view that in a different way with those benchmark contour lines. Pro also allows you to reproject data if you need to change the look of your map, change the coordinate system in which you're working. And lastly, expands file format support, so GeoPDF import and GeoPackage export and import. These expand the supported file formats from just that global mapper mobile package to some other formats that are commonly found and used to package up data for use on smaller mobile devices. So next I'll go into a few use cases now that we know a little bit about Global Mapper Mobile, and talk about maybe some ways that it could be used in the field, some common workflows, and ways that it might be useful to you. So we're going to go over a short workflow on collecting ground control points, what that might look like. Those ground control points can be used for a variety of things once collected. We'll go over a workflow where you're taking a map, you're preparing it, and then you're deploying it not just to one person or to yourself to take into the field to collect some data, but deploying it to a team of people that might need that reference map in the field for whatever reason. And then lastly, we'll go over a workflow where you're in the field, you've got Global Mapper Mobile, and you just want to collect some data. Maybe you're not doing the map preparation, you're starting right in the mobile app, collecting some data to then use for further analysis or to inform some decisions in the future. So first off, we've got the collection of ground control points. Ground control points can be used for a wide variety of things. They're very valuable pieces of data, especially when they are, very accurate. The accuracy can, of course, be increased using using an external GNSS unit connected to Global Mapper Mobile Pro, and especially if you're applying RTK corrections, if those are available to you. Ground control points can be used to rectify imagery. They can be used to QC some elevation data. Maybe elevation is the important attribute that you're collecting here. They can also be used, a common workflow is to use these ground control points with drone collected imagery that you can load into the Pixels to Points tool in Global Mapper Desktop, utilize those control points in that process of taking those drone images and creating an accurate, rectified point cloud and ortho image and 3D mesh layer. So lots of ways that those control points are very valuable. Global Mapper Mobile gives you an easy way to collect those points in the field, all within the Global Mapper ecosystem of products. So this workflow starts in Global Mapper Desktop. You're preparing your map, you're loading any base data, maybe some reference imagery, maybe reference elevation. If you're, doing a drone flight as you're collecting these ground control points, maybe the flight line or the bounds of your flight, any relevant vector features, roads, or different line work. You package all of that data up into a Global Mapper mobile package, that GMMP format. That's imagery, vector, elevation, and even point cloud data can be packaged into that format. And you transfer that to Global Mapper Mobile. So that transfer, once you've saved that file, that can be done via the mobile data management tool in Global Mapper Desktop. That allows for a wireless transfer to and from a mobile device that's on the same local area connection. You can also share these maps via email, via a shared drive or a cabled transfer, pretty much any way where you're transferring a file from a desktop or a laptop to a mobile phone or tablet. We're just getting that file from one to the other, because once it is on that mobile device, you can open that map in Global Mapper Mobile. The app will recognize the GMMP format. You'll be able to load that map in. It will appear on your maps list to reopen it once you've made some changes, maybe saved, closed, and come back to it. And once that map's open, you can begin your data collection. You've got reference data now in the mobile app. Open, you're seeing your area, you're seeing maybe the bounds of your drone flight or your area of interest. And then you can connect to that external GNSS device, set up a connection to some RTK corrections, and start collecting control points. When collecting control points, probably the most useful method for creating point features is going to be the second method that we're seeing in the screenshot on screen now, which is GPS tap. This means anywhere you tap on the screen, Global Mapper Mobile will drop a point at the GPS location. Along with that point that's dropped, some automatic attributes are going to be created, reporting accuracy and various other statistics from the connected device or the internal location services of the mobile device. You can see here that there are a variety of other feature creation methods. Here in Global Mapper Mobile, we're showing the point feature creation menu right now. We've got the manual tap, which is a points created right where your finger hits the screen. GPS auto distance and auto time drop points at a regular interval based on a configuration setting. You can add pictures from this menu and then create strike and dip points as well. Now, the manual tap, GPS tap, and auto time and distance methods are all available for for line feature and area feature creation as well. So once you've gone through this workflow, you've done your work in your field, you've collected those control point locations, you've added attributes, named them, identified them, maybe with a numeric system, so that you know what you're going to be looking at when you load that data back into Global Mapper Desktop. You save your map and you export it back to the desktop or share it with the next person who needs this data in your workflow. You save that map right to the mobile device. We can see a short video on screen playing now showing that save process. We've got a few different save options to include or disinclude hidden layers, maybe layers that you might not need to save and share with the next person in your workflow. And once that map's saved to your mobile device, you can transfer it just the same ways that you would have transferred it to the mobile device via email, a cable transfer, shared drive, or using that mobile data management tool right in the Global Mapper program. Once that data is back in Global Mapper Desktop, you've got all these new vector features, these ground control points that have accuracy attached to them, they have a location, and you can utilize them however necessary, whether it's with drone collected images and pixels to points or rectifying other data or just as a reference to your work. So the next workflow that I'm going to run through here is talking about some golf course management. And this is a more specific use case that is talking about creating a map and then deploying it out to a team of people. So greenskeepers, maintenance crew maybe that may not need to add data to the map, but it's great for them to have this data in their pocket, in their hand, with attributes attached to various vector features on the map, like different hole numbers for a golf course, maybe the area of each green, so they know how much product, fertilizer that they may need to add to it in order to care for that. You can have information about vegetation, and those folks can also add features to the map. That is a function available in Global Mapper Mobile if there are specific areas of the course or the land that's being managed that needs some maintenance for any reason. So for this workflow, we're starting sort of in the same place. We're starting in Global Mapper Desktop. We're preparing that map. We're loading all of those relevant vector features, maybe some imagery or base terrain that could be useful to anyone who's looking at that map in the field. And here we're using the mobile data management tool to package up that map, create that GMMP, that mobile package file format. This data can then be emailed or uploaded to a shared drive to allow other folks to access it. So email is a great way to distribute something to a larger number of people, or just making this file available on a shared drive where anyone who needs it can pull it down onto their mobile device and look at the map in Global Mapper Mobile. Once we're looking at the map in Global Mapper Mobile, we're seeing that this map is zoomable, pannable. Folks can turn layers on and off. So we can see in this map in particular, we've got quite a few layers describing various features in this golf course. And we can toggle those layers on and off, show and hide them. We've got the elevation shaded by a gradient here. And we can also tap on any of these vector features with the digitizer tool to select them, and then a second tap on that selected feature is going to open the attributes. This is where we'd go to edit any existing attributes that are attached to vector features, or just view the attributes to get more information about the feature that I'm looking at on this map. So this is a really great way to provide maps as a reference to folks in the field. They just need to look at this data. They may not need to edit it, but it's a really dynamic way of interacting with that map on a small screen, and then maybe even displaying your GPS location in reference to those vector features and various land features around you that are captured in the map. The last workflow that I will go over here is working on some trail maintenance or any sort of management maintenance where you may need to collect some data in the field. In this use case example, we're not starting in Global Map or Desktop. We're going to start right in Global Map or Mobile. Say you're out, you're in the field, you're doing some work, and you note something that needs maintenance, or you need to throw a track log down of a new trail or road that you're surveying. Global Map or Mobile allows you to do that from scratch, so creating that map from nothing, essentially. So like I said, we're starting just in the mobile app this time. We're not starting on desktop. We don't have any data prepared. We don't have any reference data that we have or may need to create this map. We can create a map from scratch, but it's nice to get a little bit of context in there. And so on the home screen of the Global Map or Mobile app, we have an option for online base map. Tapping this option will load in some streamed data, provided that you have a Wi-Fi or cellular data connection around your current GPS location, whether that's something from an external GNSS unit or just the internal location services of your phone. So you've got some reference data now in your map streamed from an online source. Now, for the free version of Global Map or Mobile, the available online source is going to be OpenStreetMap data. That's what we're showing on screen here, and that is the default for this online base map option. But with Pro, you get a whole host of additional built-in online sources that more closely match the online source list that you're going to see in Global Map or Desktop. And you also have the ability to add custom online sources with the Mobile Pro version. You can change what source is associated with this online base map option in configuration. So maybe you don't want to be looking at OpenStreetMap data, you want to load some elevation data by default, or you want to load imagery. You choose any available online source and it will load for your local area with that online base map option. So that's starting the creation of your map. Once you've created that map, you've got your location displaying, you're looking at the area of interest, you can use a line feature creation mode to create a track log along a trail. You can use the simultaneous feature creation to drop points of interest for things that need maintenance. Perhaps there's a tree down, or some other issue with the area that you want to capture and make a note about. Drop a point feature as you're creating a track log. You can also capture pictures of anything of interest in the field, add those straight to the map, and save all of that to your map on Global Map or Mobile. That map will be saved on the mobile device. You can, of course, reopen it, add to, edit it, and then share it from Global Map or Mobile to Global Map or Desktop, or to a colleague or a client that may need this information. Additionally, in Global Map or Mobile, I do want to touch on the field data analysis options that we have. So I mentioned we've got volume calculation, viewshed creation, and contour lines. Here we're looking at some of the results of that viewshed creation and the contour lines. Now, all three of these analysis methods are based on loaded elevation data. So you're going to have to prepare that data and have that data layer in the map in order to use these, but it provides a way to just get a little bit more information from your map while you're in the field. So viewshed analysis can be done based on a selected point or your GPS location. Wherever you are, you can analyze what you're seeing based on some basic parameters. And then contour lines will run for the elevation data that is loaded in the map. It allows you to create those benchmark contour lines, and you can then turn off that shaded elevation layer, which may make some vector features or imagery more visible on that mobile map, and still see those elevation reference as those line features. So quite a bit of value in creating those contour lines quickly in the field as well. So that brings me to the end of this information session here on Global Map or Mobile. I hope that maybe you learned something if you're not using Global Mapper Mobile. Maybe you're interested in checking it out. As I mentioned quite a few times, it is a free download from the iOS App Store or the Google Play Store. So go ahead and download it. And if you're interested in some of those pro features, it is just a yearly subscription to unlock those features and have access to some of that advanced functionality. So thank you everyone for listening, and thank you for attending GeoTalks. I believe that we are going to take some questions if there are any at this point.
Yes, absolutely. I've got one question to start, Mackenzie, and that one is, are there limitations to what GNSS receivers can connect to the app? For example, we have an MLID reach receiver. Are these compatible with the app?
Yeah, so the MLID Reach is compatible with Global Mapper Mobile. The newer Reach RX is currently whitelisted with iOS. Just a little background, Android tends to be a little more open with what external devices you can connect to an app via Bluetooth. iOS is a little bit more locked down. So I believe that any available device should be able to connect to Android, iOS, the new MLID that they tout as having iOS support. Does work with Global Mapper Mobile, and then there are a few other vendors as well, Bad Elf and Trimble through their Trimble mobile management app, and a few others. If you guys are running into a device that you may have that you want to work with Global Mapper Mobile, you're having trouble with that, or it's not connecting on Android or iOS, I always encourage folks to reach out to our technical support. We've got a wonderful technical support team here at Blue Marble Geographics, happy to answer your questions about this topic or any other.
Awesome. Thank you so much for answering that, Mackenzie. Our next question is, we've got someone named Kyle wondering if there's any support for Android Auto or Apple CarPlay. I'm not sure what the use case would be for that, but it's a question.
I do not believe that we have support for CarPlay at this point. You know, you can set up, of course, before you start driving, that automatic distance or time and be recording a track log as you're driving. Definitely recommend pulling over to do any additional messing with the phone, but no explicit CarPlay support at this point.
Awesome. And another question, I think you touched on this during your presentation, but I've got someone wondering how long they can use Global Mapper Mobile freely to learn. And I believe the answer to that is that the app is free and that there
Yes,
are additional mobile pro features.
Yep, the base version of the app is completely free. You get it for free for as long as you want to use that standard base version. If you want those pro features, that is a yearly subscription. I believe the price on that is $50 for the subscription, so not a huge fee on that, but the free version is 100% free. So definitely encourage you to try that, and if it works for you, then go for it and use it.
Absolutely. And we've added that link to Global Mapper Mobile in the chat so people can check it out, download it, all of that fun stuff. Got another question for you, Mackenzie. What is the accuracy we can get when using the app after getting RTK corrections? Is it device dependent?
Yeah, so it is device dependent. It depends on the accuracy of that external GNSS device and the corrections. If you can get a good lock on those RTK corrections, you can, get centimeter, like survey grade data being collected. But it does very much depend on the resources that you have available, whether you have a strong connection to that RTK correction that's being applied. So not a straightforward answer on that one. It is fairly situational and fairly dependent on what you have available.
Awesome. Have a few more questions for you. We've got someone wondering, can the software import DXF files?
So Global Mapper Mobile can't import DXF files. We do not support the wide range of file formats that the desktop Global Mapper supports. And the reason for that is that the mobile devices, well, storage is much larger than it used to be even a few years ago. We're trying to keep that process simple for working on the mobile device. The work of preparing all your data, importing that DXF, DWG, any of the formats that are supported in the desktop would be done on the desktop side, and then you would package all that data up into a mobile package format to share it with the mobile device. This makes it so that you can have, multiple files all packaged together. They'll retain that layer structure that you'd see in Global Map or Desktop, and be available on the mobile device that way. So short answer is no, we don't support that format on mobile, but there is a way to get that data onto mobile. You just have to do a little preparation and data organization in the desktop application.
What is the basic difference between the standard version and the pro version of Global Mapper Mobile?
That's a great question. So the standard version for the GPS location display and feature creation, you're using the internal location services of your mobile device. Those tend to be a little bit less accurate. So you're not getting quite as accurate data that you're getting collected there. There's a limitation on how many available online sources you have. You don't have that simultaneous feature creation for creating a track log while dropping some points, and a few other features there. The big selling points for the Mobile Pro, the main reasons why we see people upgrading, are that connection to an external GNSS device and access to that Entrep client for RTK corrections. That's going to greatly boost the accuracy of the data you're collecting. So if you have that hardware available to connect to, and you have an RTK correction source to log into, you probably want Pro in order to take advantage of that. Also, just the expanded list of online data sources. So the ability to stream some imagery in, even create some custom online sources to stream in, just like you would in Global Map for Desktop. So those are the big points, although there are smaller features that Pro unlocks as well.
All right. Thank you so much, Mackenzie, and thank you for your great session. We're really excited to see what people do with Global Mapper Mobile this year. And in the meantime, we're going to welcome our next speaker, who is the 2024 Global Mapper Master winner, Simon Brown, presenting on mapping the SS Thistlegorm. So thank you so much, and get ready for Simon's session.
Thank you so much for having me, Meg.
Good afternoon, everybody, and thank you very much for joining. And what I'm going to be discussing for the next 20 minutes or so is the Thistlegorm project, which is an ongoing project that we've got in the Red Sea. It's a collaboration between a couple of universities here in the UK and Alexandria, and the University of Alexandria in Egypt, and it started in 2017 with the simple goal of creating a baseline of the SS Thistlegorm. I'm just going to switch screens because I want to start sharing content, so just bear with me. Thank you very much. I'm also going to turn my camera off and concentrate on the screen. There we go. What we have is the SS Thistlegorm. Now, she is lying in 33 meters of water in Egypt's Red Sea. She is a Second World War merchant vessel that was attacked and bombed and sunk at anchor, hit by a bomb from German aircraft that landed in this area here. This is hold number 4. And this is the area which, although you can see is completely wrecked, is an area of interest. We'll come back to that and explain why later on. But in 2017, we managed to cover the whole wreck from the anchor at the bow right through to the deck guns at the stern. Now, although she is a merchant vessel, she was armed and is known as a DEM, defensively equipped merchant ship. That was the first year we went. We managed to cover, like I say, all of the exterior that you can see here, the internal spaces, including the cargo decks. There's 2 cargo decks that are stuffed full of vehicles, motorbikes, Lee Enfield rifles, Wellington boots, water boilers, all sorts of equipment. And because the vessel was on its way from Glasgow in Scotland, carrying war material for the British effort in North Africa to eventually reach Alexandria, but never made it. So 2017, big survey, covered most of the ship, most of the vessel, and the intention was to create what we call a baseline, because this wreck is probably one of the best, finest wreck dives in the world. It's in fairly shallow water. There is typically very good visibility. It's also warm, and as such, it's very popular. We estimate that this, as a dive site, earns the local economy, or generates for the local economy, about $5 million US every year. And although this is great, it's good to see people exploring our maritime history and our military history, it also comes at a cost, because the sheer volume of visiting divers and dive boats is starting to damage, or is damaging, the vessel and its structure. Because what dive boats typically do is they will moor onto the boat, and they will choose something like this deck mooring bollard here, and they'll then move along and tie off against this one here on the bow, for example. And of all the points to choose, these ones are the best. However, some vessels have been using the anchor chains on the bow here, or some of the guardrails, and it's just has been literally ripping the wreck apart. So to create a baseline was going to give us then a record that we could quantify the damage over time. Anecdotally, we've heard over the years that parts have gone missing, things have been removed, artifacts have been stolen, and there were structural changes to the vessel, but we really needed a baseline to be able to prove it. So that's what we set out to do. And this is the result. It's took about 25,000 images and 60 days of processing back in 1997. But it's delivered us a really, really good and very accurate baseline. GPS positioning is typically denied underwater. It is possible to get it, but it's also very expensive. The other problem as well is in the Sinai, which is quite a sensitive area in the world, and the Egyptian security forces don't like people carrying survey equipment in. So we're not allowed to take anything in that could actually survey it. But we still got a very accurate result of the model. There's a whole paper that describes that. I won't get into it too much, but basically using a series of constraints, GPS positions, and scaling, we managed to get the wreck and its artifacts within 1% of the real world. 2022, we went back and surveyed this area, hold number 4 again, because we thought there was some dynamic activity in here. We proved right. We also found and located the locomotive boilers, part of the cargo, with 2 Stania locomotives, heavy freight locos. This is the boiler from one here, and way out here we found part of one of the locomotive wheels, and on the starboard side we found the second boiler, again upside down, inverted, but just, I don't know if you can see, but there's been quite some damage and deformation to this. This boiler should be tubular, but it isn't. And the question is why? Why, and what has happened to this vessel that's led it to be in this condition? And really, the clue is in this area, because although it was attacked and bombed, it did catch fire. But it wasn't the bombing that actually sank the vessel. There was a secondary explosion recorded by eyewitnesses that has literally torn the wreck in two. You can see there's a huge gap. And being curious, can't help but answer that question. What caused that explosion? And we think we have the answer. So we'll go into that shortly once we're in Global Mapper. So that was really the field work. It's quite a big project. It was probably the biggest underwater survey at its time. It's subsequently been beaten comfortably by the Titanic and Shackleton's Endeavour. But I'm quite happy to let those ships take that crown. But photogrammetry in this case has produced quite a lot of data for us, and the way that we've managed it is in Global Mapper. Now, without Global Mapper, I can honestly say that this project would be a lot more complex and difficult to manage and work with. than if we didn't. The sheer quantity and diversity of the data that we've got, everything from like here, we've got the digital elevation model that's expressing depth of water or depth of the seabed and the object in different colors. We've also got the orthomosaic. This is from the 2017 work. And this, the level of detail we managed to get is quite incredible. It's 1.1 millimeters per pixel. So we are able to zoom right in and examine just about anything we like and ask questions and get answers. And because it's scaled and we know that it's within 1%, we can also measure objects and find out what they are. So the first job that we did was really build up the data, the rec, and then in the second year when we went back in 2022, we started to add on the additional information that we're starting to find, like the boilers and other artifacts. And we started to look at the seabed and find out what's there. And the short answer is a lot. Way off to the southeast is the remains of the mast that was originally between hold number 4 and 5, just here. There's also a locomotive wheel that's even further out, way out here. Just have a look at that. You can see there's a locomotive wheel there. And we then start to ask, okay, how does this all fit together? And one of the tools that we've used extensively in Global Mapper is the ability to draw in unreferenced, unprojected data. And we were lucky when we got back to the UK in 2017, we did a bit of research and found a copy of the builder's plans in an archive. So we've brought them in, and it allows us to then manually rectify and place over the ship using the holds corners primarily and the bollards, the deck bollards as control points to anchor the image in. And it allows us then to start understanding, okay, just how much of the ship is missing, how much is it dislocated, what's gone, and crucially things like where is the aft mast, and it's actually this round feature just here. So if we want to measure how far the mast has now gone, we can select it, zoom in here, pick it, wander off, and say, okay, it's now 158 meters from its original position. And from the deck plans and from contemporary reports, we know that the ship was carrying these 2 locomotives. They're now in pieces. You can see this is part of it. This is the smoke box. But then it raises the question, well, how big is it? What else is missing? And how can we sort of help people understand that this is only a small part of the locomotive? We know it's big because we found the boiler here. But explaining that, interpreting that can be difficult. So if we just go ahead and have a look at this here, this is the engineering drawing of the Stanier, and we've overlaid it, again, manually rectified it, dropped it in so that we can see and understand its position. That helps people understand and think, okay, yeah, I get it. There's a lot of train missing. And again, why did this train end up this way? And where was it stored? And we think this train here was stowed on the deck alongside hold number 4, somewhere around here. So 20 meters, that's moved. Now, the boiler themselves, we know, weigh 22 tons, and that has gone approximately 57 meters, and the starboard boiler has gone even further. So we're starting to sort of like collate and understand and really start to interpret and get an idea about what's gone on. The other thing that we managed to do as well, if I just turn that off a second and just bear with me while I navigate around. It's got a lot of data here now, and sometimes I need couple of seconds just to remind myself where everything is. The lower cargo deck was an area that we were extremely interested in. This is the lower cargo deck actually embedded inside the ship, and you can see the rows of lorries, 1, 2, 3, 4, 5, 6. These are Fordson lorries. There is also a series of lorries here, parked up here and here, And in the bow area, we've got another 6 fuel tankers, actually. These are aircraft refuelers. And we thought that this area was quite dynamic. We weren't sure. But because we got a very good orthomosaic out of this. This is 1 millimeter per pixel. You can see there's 3 Norton motorcycles. There's a Wellington boot here. There are a lot of fish in the way, but we can live with that. It makes it look quite pretty. We didn't get a chance to have a look in this area again. We ran out of time in the second second visit, but we did find out that we had a visiting diver, a guy that just enjoys photogrammetry, and he'd swum around this with a video and a couple of GoPros on video, which isn't the greatest tool for photogrammetry, but when you've got nothing, this will do. And he very kindly shared it with us, and we've got here his manually rectified and manually scaled orthomosaics. And what this allowed us to do was to do a visual comparison between 2017 and 2022 and find out basically what's moved. And if I just come down here, there's a couple of things we've done. First job was when we came back was we marked the positions of all the vehicles using Global Mapper so we could understand how many there are, total up the number of motorbikes, that kind of thing. Very useful tool, also useful for explaining to people where things are. What we were looking for, though, was particularly in hold number 2, objects that have changed. So everything in red, everything in green, and everything in orange is something that's happened. The green is new, it's come in. It's present in the manually rectified orthomosaic from 2022, but it's not present in the previous year one, 2017 one. Orange was positioned 2017, red is moved to. And you can see there's quite a lot of movement going on. It's a bit of a concern, really. There's not a current that runs through here, so we can't blame that. We think, in fact, we're quite sure that this is visiting divers interpreting, touching, picking up things, getting interested, putting them down again in a different place. Simple as that. It's not malicious, but it's not welcome either. And the reason we think it's we think it's divers is quite simple. If I just zoom in on this area here, they write their name in the silt. So, you know, this isn't good practice. This is not helpful to the wreck and its condition. And it's also pointless as well, in my view, because very few people see it. So, but anyway, that's what they're up to. So 2017 data, very good, very robust, very accurate. 2022 data, less robust, less accurate, not geo-rectified, not geo-referenced, not scaled, not in any way constrained at all, but we're still able to consume it as a manually rectified layer in Global Mapper, which for us is priceless, absolutely priceless. So that's that. We also have took a look at this area here around hold number 4. Again, there were 2 questions we wanted to answer. Is there anything in this hold area that we could identify that might be a cause of the explosion that sank the wreck? It was clearly significant. The boilers, the locomotive boilers, have gone between 20 and 80 meters away from the ship. So some great force did that. And then the second issue that we wanted to look at was, is this area changing in any way? And you'd think that probably not, but this area here, this is the prop shaft. So it's a very substantial piece of solid steel sticking out into the water. And this point here is used frequently by the dive boats mooring up. You can see one of their mooring lines here. You can also see they're using it quite a lot because it's oxidized. It's frequently changing. People are using this point quite a lot. So one of the questions we asked ourselves again was, what's happening? Is this an issue. And if I just scroll down, there we go, have a look at the prop shaft. The prop shaft outline, this is actually taken from the Lloyd's Register records. They have the blueprints of the original design of the prop shaft. And this has been drawn on to scale, and you can see straight away we are losing material from the overall diameter of the prop shaft. It's starting to get sort of like a neck or a waist here. At some point, this is going to fail. Maybe some years off because it's 12 and a half inches in diameter and it's solid, but it's going to happen at some point, unfortunately. So we're proving already that this is changing. And then the question is, well, is there anything else that's been disturbed in this area? And if I just scroll down here, I want hold number 4. And if we have a look at the object locations, everything in orange we know is moved because we've got another orthomosaic and another DEM, another point cloud. We did a point cloud analysis and found small variations, except for in one area just here, which we found a massive one. If you can see here that there is like a coil of rope or wire, we think that's copper, but we're not sure. We would like to go back and have a look, but it's been stolen. And we think it's been lifted for its scrap. Sometime during COVID, when the wreck was quiet, there was no dive vessel, no diving activity. But at the same time, people have still got to earn a living, make a living. So we think it was raised during COVID. There are other examples in there. Like I say, if we get the chance to go back, we will have a look at those and try and guess if it's copper. We think it's copper wire, in which case it's got scrap value. All the red bits are things that have moved completely, dislocated. So this clearly seen some disturbance here. And there are some new objects that have appeared as well. Not sure how, but they have. And you can see that there's like a debris trail. If you look this sort of leading out this way, this spar here from inside the vessel, this rib, was originally in this position 2017, 2022. It's now facing away from the vessel. This tube here has moved. This has been dislocated. This object here has changed, and so it's moving. And it raised the question of what are these objects? Is there anything here that is dangerous? Because the vessel is carrying ammunition. There are boxes. These are boxes of 4-inch shells. There's literally hundreds of tons of those on board. There are also some 15-inch shells. These are huge objects, 15 inches in diameter. They weigh about 780 kilos, filled with explosives. And there is also boxes of smaller ammunition here. Clearly, a lot of ammunition it's been left lying around, and that's part of a cargo. We would expect that. However, there are where are we? Just have a look. Need to find the objects. There we go. Unexploded ordnance. Bear with me. 15-inch shells are here. We'll come back to those. There's 6 of them that we found. Boxes of shell cases literally everywhere, scattered far and wide. And these objects here, these objects in red, these are British Mark 1 to 4 depth charges. Now, they're very distinctive shape. If I just turn the layer off again, you can see that they've got like a taper on one end and a plain end the other. They are quite large. They're about 2.5 meters in diameter, length, and they're about 14 inches in diameter, and they are filled with 340 kilos of an explosive called amatol. So using the combination of 3D model and the orthomosaic, we can interrogate what's there, find out what it is, and have a very good educated guess about what the object might be. Now, left alone, these are fine. They're going to sit there. They're just going to, be quietly left alone, undisturbed, doing their thing. However, we have a look at the hold number 4, 2017 positions and 2022 positions. Sorry, not that one. That one. You can see that this airdrop mine here in orange and red, and this airdrop mine here in orange and red has moved. So we are seeing it being disturbed, and we don't think this is divers fiddling or interfering with it. We think this is basically mooring practice. We're very close to a mooring point, and you can see that the mooring line, it's got like a loop on it, and that loop obviously used to secure the vessel to an object, in this case the prop shaft. But if you're not quick at recovering your mooring line when you're leaving the site, and you let the line dangle, and then the vessel moves and drags that mooring line across the seabed, it's likely to snag everything in its path. And we think that's what's caused this. It's not good to disturb unexploded ordnance. It's best left the stuff alone. There is a case here in the UK of a fishing vessel that was compromised to the point of flooded engine room, wrecked electrical systems, wrecked galley, and crew members suffering life-changing injuries when their potting line they were fishing at the time snagged a 250-kilo German bomb from the Second World War. It then functioned and did severe damage. Now, there is one advantage here on the Thistlegorm, is that all of the mines and all of the ammunition is cargo, so it will not be fitted with a fuse. The fuses for these weapons would have travelled separately. So there is less risk, because the fuse is typically the most unstable part of munitions. But amatol does degrade with age, and disturbing it doesn't do it any good at all. So we would encourage people not to snag that, damage that. We know it's inadvertent. We don't believe people are doing it for malicious reasons or anything like that. It's just ignorance. So we will be doing our bit to try and help out there. With respect to mooring damage, if we have a look at the forecastle bow area, this is the 2017 recorded positions of the anchor chain. You can see that it runs down here and then runs off to the seabed. This is the starboard anchor. The starboard anchor was actually deployed at the time, and the port anchor is in its hawser. Now, some point between 2017 and 2022, the port anchor chain failed, and the anchor is now lying on the seabed. We did a little model of this area just to capture this change. You can see that the anchor chain is gone. It's now lying on the seabed alongside the anchor. The red anchor chain here is the 2022 position. 2017, we can see that things have shifted around. We know people tie their dive boats off to this chain, and it is wearing out. And this actually has a very modern and relevant application to some of our clients, because they are using photogrammetry to measure mooring chain wear for things like North Sea oil rigs. You know, when they're anchored into the sea, they're held down by chains, and the chains wear. They need to measure the wear rate so they can do predictive and preventative maintenance, replace the chain before it snaps. So we're capturing things like that. And the answer to the question of what sunk the Thistlegorm is actually in hold number 4. If we just have a look at, where are we? Just let me collapse this a little bit. We are looking for the 15-inch shells. There we go. These shells, there are 7 of them that we've identified, are not the actual cause of the explosion, but their presence on the wreck gives us a good clue. These shells, as I said, they're very heavy, 780 kilos. They're designed to be fired from a battleship with a range of about 38,000 yards. And the propellant needed to push these that far is quite significant. Each shell would have required 4 what's called bagged charges. So if you imagine like a silk bag full of explosive, there have been 4 of them, and each bag would have weighed 47 kilos. So you're getting close to 200 kilos of cordite needed to push each shell up the barrel and onto the target. And we think it's likely the ship would have been carrying around 100 rounds, 15-inch shells. So we're looking at something close to 20 tons of explosives on board, because the bagged charges would have been carried with the shells. There's no point carrying them separately. And the eyewitness account of when the vessel sank was of a large sheet of orange flame coming out of hold number 4, which is the kind of explosion you get. It's quite a low pressure explosion from cordite, and we think it's cordite that actually blew the wreck in two. So thanks to photogrammetry and a spot of mapping and measuring, we're able to prove exactly what sank the Thistlegorm. It's just been a fantastic little project. I've really enjoyed it. So hopefully it's sort of giving you an idea about what we use Global Mapple for, because the answer is quite a lot. We've only touched on it. There's so many other things that I could talk about, but I think Meg is waving at me, and it must be my time is up.
Yeah, so that was an amazing presentation. Thank you for sharing with us what you use Global Mapper for. We're going to be taking some questions that the audience has, so I will start that now. So one of the questions that we've got is, what camera did you set up, or what camera setup did you use to capture the images?
D700 with a 16mm fisheye. That in a suitable housing with a dome port. So working underwater's got its own special sort of requirements. It's like real photography, but like 10 times the cost at times. So yeah, that's what we used, D700.
Nice.
Nowadays, I would probably approach it with a stereo camera system, so we get scaling inherent, because that would have saved time.
That makes a lot of sense. So the next question that we've got is it possible to see if the ship is sinking further into the silt?
Yes, the short answer is it would be. The longer answer is we don't think it is. We think the ship itself is actually quite stable. The point canal analysis of the stern area that we did between 2017 2022 really didn't show any structural changes. And we also did a little survey around hold number 1 as well, because the deck has actually slightly collapsed on the port side. But looking at it, that hasn't moved. And the more I look at that, the more I think that damage was actually caused when the bow hit the seabed. It buckled the deck. It went down quite quickly. We know that. So yeah, we could find out if it's sinking, but the seabed's actually hard rock there, so it's not going to go anywhere.
Very interesting. So we've got another person asking what the biggest challenge was for you when working in an underwater environment.
Right. Yeah, that's a good question. Visibility typically is the key to great underwater photogrammetry. If you've got clear water, the job gets a lot easier. If you've got suspended matter, particulates in the water, then it gets to a point. The fish are less of a problem, actually. Only once have I had a problem with fish. It's generally bad visibility. The fish did cause a problem once on one job where I had a big school of fish around this. It was a tank, a Second World War tank on the seabed, and the fish schooling around the turret actually ended up being built into the model because the software recognized all these fish as being the same thing. And it built this wonderful sort of brown, silvery, amorphous ball of. So I had to go around and mask it.
Super cool.
It wasn't. Yeah, it's a great story, but it was a lot of work masking all the fish out. So
I'm sure.
Yeah. So yeah, it has its own challenges. The other issue as well is time, along with no GPS. All of the things you don't get with a drone, really. Yeah. You do have to be careful and mindful of what we call task loading when you're diving, because if you get so focused and so into a job, you can neglect things like how much gas do I have left, what are my decompression requirements, and do I have enough gas left to meet my decompression requirements? Because sometimes, if you're down there long enough, you can't just go straight to the surface. So yeah, it's a different world. I love it, but it's certainly a different world.
That's awesome. Yeah, I'm sure it has lots of challenges, but also lots of great things to
Yeah,
explore.
it
So
does. Yeah, it does.
we've got another person wondering what the most valuable global mapper tool was in this workflow.
Oh my word. All of it, the whole thing. Yeah, the ability just to build up layers of information and to mark positions of stuff and understand how they relate and how they went together, how the vehicles were loaded, where all the vehicles are, where all the objects are. I mean, we've only touched on some of the objects. We even detected using DEM analysis the fact that divers exhaled gas had rusted through the plate, the deck, and had bubbled up the linoleum in one of the rooms. But we could do that by looking at and examining the DEM, and then you can draw around it, mark it, and say, look, this has changed. Probably the best thing is probably the most basic thing, really, which is the ability to manually or rectify things. So we've got builders plans that are drawn on waxed Irish linen paper, some really old paper, but they were digitized so we could bring them in, exclude the white background, and then understand where all the hatchways were, where all the air trunking, all sorts of stuff. But it's being able to drop on engineering drawings helps people understand how things go. So yeah, it's a fantastic tool, really good.
Well, thank you so much for joining us today. I think that's going to
No
wrap up
problem.
we're going to wrap up our Q&A.
Yep.
And yeah, thank you so much for joining us and for sharing this workflow with us. It's an amazing project, and we're really excited to see what else you do. So thank you
Thank
so
you very
much for
much.
joining us.
Yeah, no problem. There is a link to the paper that covers this on our website, which is accupixel.co.uk.
Awesome.
Hi, thanks for joining me today. My name is Jeff Hatzel. I'm a product manager at Marble Geographics, responsible for Global Mapper Pro and the R&D team. Today we're going to discuss AI-powered tools in Global Mapper Pro. Some of these have been around for a bit and others are newer and still in beta. We'll start by talking about what is AI, or at least break down some of the key ideas in relation to how we use it in Global Mapper. We'll look at the specific tools in Global Mapper Pro that have some built-in AI methods. And then, time permitting, we'll go ahead and take a look at a use case or two in Global Mapper Pro Live. So, what is artificial intelligence or AI? We hear that term quite a lot these days. At its most basic, one way it can be defined is a computer science discipline that focuses on accomplishing tasks which require human-like intelligence. That could be things like pattern recognition, learning from data, problem solving, and image generation like my graphic on the right here. And I'm sure you all see this in everyday life as well, right? It's kind of hard to miss these days. And if we think about just some of the generic ways we might see it, used in our everyday lives, we see it in the healthcare field where AI is being used for image analysis, or maybe you're someone who trains for sport or exercises, and you can use an AI coach or trainer that adapts to your performance and define goals and things like that. When we think about AI a little bit more deeply, two of the main, I guess we'll say, sub-disciplines of AI that we'll talk about today or that are relevant to the geospatial world and our workflows in Global Mapper Pro are machine learning and deep learning. The machine learning side of things is maybe a little bit more straightforward. Right here we have computer systems that are basically trying to learn from data and make predictions and decisions. Generally speaking, it works well with smaller data and ends up being a little less computationally intense. And it also requires more user input before processing. So think of something like providing training data or other examples of data that you're trying to find as an end user. It's very common in a machine learning workflow. A deep learning workflow is a little bit more in-depth in terms of the analysis that it's done, and it requires quite a substantial amount of data. Generally speaking, we can consider deep learning as part or a subset of machine learning, where we're leveraging what's called artificial neural networks, which recognize complex patterns in data. And that's how we can think of those. On the user side of things, deep learning inputs are much more streamlined. But the development side, those of us who are creating the software have much higher engineering efforts required. And that's because typically deep learning models are geared to a very specific task. And so if you're meeting that task, there's very little then that the user has to do to kick that off. Whereas we, the developers, have to build that model to perform that task well. If we think about some applications of these methods, we can consider, machine learning for things like email filtering, where you mark certain things as spam, and then future items that hit that criteria also get marked as spam. Maybe on your streaming services, you see shows or movies or whatever that are recommended for you to watch next based on analysis of your previous watch history. And then those of us who use any sort of GPS app or navigation while we're driving, right? Those apps look at current traffic and travel predictions and analyze those live and historic patterns to figure out time estimates and best routes to take. In our day-to-day life, we see deep learning used in our photo libraries where, maybe photos are grouped by face because we're using facial recognition software. To find, yourself or your friends, whoever, in your photos. Autonomous driving, now that we're seeing happen more and more, in recognition in response to objects that may be in the path of the vehicle. And then even our banks, fraud detection analysis and spending patterns and things like that. So really, we're starting to see these AI, machine learning, deep learning based methods all over the place. Of course, what we care about is how and where they're in use in Global Mapper Pro. There's two main sections of Global Mapper Pro which have AI-powered tools. That is the automatic point cloud analysis tools, and then the new Insight Learning Engine, which was just released in beta this past fall, has a variety of deep learning image analysis models. To start, we'll go ahead and take a look at the automatic point cloud analysis tool in Global Mapper Pro. Over the years now, many of you have probably heard me discuss, point cloud analysis and classification, segmentation in Global Mapper Pro, because that's something that we really pride ourselves on and how well we do it. In general, what these tools do is leverage a few machine learning techniques that allow really for more accurate identification of objects in a point cloud. And one of the benefits to these methods is that they allow us to be a little bit more flexible in the types of data we're classifying from a variety of sources, right? So it could be terrestrial point clouds, aerial, photogrammetric, etc. These machine learning based methods give us the ability to analyze that type of data. And also, we've implemented them in such a way that users have the ability to conduct custom training and classification as well. And we'll kind of look at all of that in a second here. So the two relevant, I would say, machine learning components in point cloud analysis are geometric segmentation and semantic segmentation. So geometric segmentation is effectively the segmentation of a 3D point cloud. Sometimes you may hear that called spectral partitioning. What this process does is it helps us identify specific features or objects, if you prefer, in the point cloud. Segments are created based on a variety of point cloud statistics and attributes. So that might be the intensity, the color, and a variety of geometric values, all of which allow us to create and identify specific segments. So on the left-hand image here, all those unique colors are unique independent segments. The second step then is semantic segmentation, and we can think of this as classifying or really giving a meaning or a name to the previously identified segments. So we have some built-in classifications, and those are things, like buildings and trees. Generally speaking, we expect those to fit a certain set of parameters or fingerprints, as they're called. And we expect these to regularly meet the criteria for those structures. Of course, users can edit that. And then a maximum likelihood classification is the process that we use to actually classify those segments into the classes that we have built in here. And one of the benefit of these segmentation-based methods is that it allows us to conduct that built-in classification and then follow up with a custom-trained classification when needed. Users essentially can go ahead and identify an object or objects of their desire. So in this case, you'll see I've identified pools here on the right-hand image in the red boxes. And if we look at that a little bit more closely, when it comes to the initial geometric segmentation, users do have full control over the parameters. They're not required to use them explicitly as we have them built in. And so after they run that built-in classification, which would be the first image here, they can then even further tailor the segmentation to find objects of interest. So in this case, that's what I did for the second image. I was targeting the airplanes here, and you'll see that now the airplanes are made up of a set of colors. Each of those colors is a segment of the airplane. The ones in red are ones I grabbed and selected to say, we're going to use these as our training samples. And then you'll see in the third image, after that training is done, we say go ahead and find all of the other planes as well. And now we've gone ahead and used that custom classification that we trained to identify airplanes. But that again could be applied to really any feature that has a consistent kind of geometric structure within the point cloud. We'll change gears here a little bit away from point cloud analysis and look at image analysis in the Global Mapper Insight and Learning Engine. So currently the Insight and Learning Engine features robust deep learning powered image analysis tools. These currently include 3 built-in models for land cover classification, building extraction, and vehicle detection. And then on top of that, options to fine-tune and fully retrain those models too. So land cover classification allows us to analyze or input a multi-band raster image, and the output from that is a rasterized land cover classification map with a variety of land cover classes which are identified. And we'll look at all of this in a little more detail coming up here right in Global Mapper. Building extraction then is the process of extracting a vector building footprint from imagery. So we'll see our source image on the left is just the RGB imagery, and then on the right we've now extracted vector footprints of those buildings. Not pictured here, this process also creates a binary raster grid, and that's really what's used as the basis for the extraction. So the boundary of that grid where it thinks there are buildings is then extracted to create the approximated building footprints. And then lastly, we also have vehicle detection, and vehicles are detected via essentially bounding box in any multiband imagery. That could be in a suburban setting like here, or in a much more urban setting, you'll see on the right here where all the vehicles have been identified in the imagery itself. But let's go ahead now and we'll move over to Global Mapper Pro, and we'll look at the app kind of live here as I work through it. So in Global Mapper here, what I have loaded now is multi-band imagery, and it's a cropped image. I believe, I want to say this is in Tennessee, but again, that doesn't really matter now. What we're going to look at is some of the deep learning tools associated with the Insight and Learning Engine. We have talked in the past quite a bit about our point cloud tools, and just for the sake of time today, we're just going to look at some of the newer Insight and Learning Engine stuff. But all of those old point cloud related recordings are available on our website and our documentation on YouTube, so you'll be able to find those as needed. So just for reference here, we'll look at the metadata for this image. Noting that we have about a quarter of a foot, a little less sample spacing. This is very high res. And we have 3-band imagery here. So this happens to be RGB. And it's what we're going to use for a variety of detection and land cover classification right now. These new tools live in their own toolbar. Right now that toolbar only happens to have 3 buttons on it: land cover classification, object detection, and then creating a model, which would be fine-tuning or retraining our models. I ran this earlier just so we didn't have to wait for any processing, but we'll go ahead and pop the tool open and take a look. And one of the nice things about these deep learning tools that I mentioned earlier on in my slide is that when it comes to the user interaction, it's a fairly quick and straightforward process. There is not too much that the user has to do to kick things off. They can choose the type of raster image that they're working with. That holds true for anything, building extraction or vehicle detection. There's different models here, and they should you'll be able to pick whatever you have available here. Each model will have a corresponding description, so you can see any important information about what that model is trained for. For building extraction, you can post-process the vector data. So typically what I'll do is I'll regularize the output, and that just helps us have a little bit more square edges as we might expect a building to have. Vehicle detection is simpler. Since we're just creating bounding boxes, there is no extra options here in terms of post-processing or anything like that. It's simply a vehicle bounding box there. And then when it comes to this custom model tab, we'll look at that in a second. That's where anything that we make or fine-tune will show up for the respective objects. Running this process is as simple as clicking Start Inference. We won't wait for that now. We're going to go ahead and look at some outputs that I ran earlier. So let's take a look. So the building extraction process, in this case, technically makes 3 things. This is what we would consider really the intermediate building footprint map. So these are locations that we think are buildings. The white pixel represents the building. But probably more fun and more useful is for us to look at the vector outputs of the building footprints. We also get the original non-regularized option, but since I chose to post-process it, I have that saved as well, and I could see each building has its own footprint. Maybe we got a little overconfident right there. That's probably not a building in the road, but otherwise these buildings look pretty good. And these are, again, traditional vector features. You can save them out of Global Mapper or work with them, however else you may need to. The vehicle identification process, and there's not a ton in this neighborhood. We can see some in the streets here. A couple maybe parked over here too. Then identifies the bounding boxes around vehicles and where they are on the imagery. Overall, does a really good job, and this imagery is technically a little lower resolution than what our initial models were trained on, but not by much. And we can see we identified mostly all of our correct vehicles in the images throughout the neighborhood here. A lot of them parked at houses and things like that, rather than looking at a busy road. And so the last thing I want to look at is the land cover classification. We did not look at that tool initially, but it's set up very similar to the others. Again, you would choose your band count and the model you may need to work with, and it should pick this automatically. I don't have a 4 spectral band image loaded, so it will automatically figure out which data set is loaded, and if I had multiple, I could choose kind of what layers I wanted to work with here if I didn't want to work with all of them. One of the interesting things about this, I always like to point out, is generally speaking, when we're performing analysis, we often think, oh, higher resolution is better. It will get me a clearer, more accurate output. In the deep learning world and with deep learning models, that's not always necessarily the case because the model is trained on a very specific type of data. The reason I'm showing this is it's going to be incorrect, and I want to highlight the process of fine-tuning it and cleaning it up where there's some mistakes. We saw earlier we were looking at about a 1/4 meter resolution in the imagery. This model was originally trained on about 1/2 to 1 meter resolution. So the data we have is much higher resolution than the data the model was trained on. And so the original output, while pretty good for never having seen data of this type before, we certainly see up on the northeastern side of this data set, right? There's some confusion up here between water and bare ground, and some of the other bodies of water don't do a great job of being identified. So what I did then is I used our fine-tuning and retraining tools to create a fine-tuned land cover model. And what I can do is I can generate training data, and I did this a little earlier, but we'll go ahead and take a look. And you'll see I've already drawn on here, we can see I drew and corrected this, water and shrubbery to be bare earth. I cleaned up what the pond should look like. And there are a variety of quick ways to do this. Again, this assumes you may have ground truth data that already exists, and you don't ever have to do any of this. But I wanted to highlight the ability that it can all be done. So maybe what we want to do is just very quickly, I'm going to say I want to swap colors. So I'm not going to rerun anything. That takes a bit of time. But let's say I, in fact, want, for example, we're going to just go to unknown for right now. And we're going to change water. So I'm going to go ahead and draw a box around my water, and it will change just that water to the unknown class that I just set. Could always undo that if I make a mistake. I don't really want to save that as water. But really handy ways to get in there manually. Not only can you switch colors, you can fill color and draw an area, or apply a certain color to a certain region in large groups. I really like the replace value because it lets me target one type of incorrect class and kick it over to another class. So let's, for example, say, these areas in the forest here are probably, you could argue they're barren or maybe low vegetation. For our sake, let's say they're barren, and I want to change any of the impervious here, as it's called currently, to barren. So even if I get other classes in here, the only things that are getting changed are the impervious class that I targeted. So a really quick and handy way to clean up our data sets. You can always validate your change, and that'll make sure that the classes you provided match your model that are built in. And then once that's done setting up the fine-tuning or the retraining, there's a few parameters here available to us. The iteration is how many times the model repasses over the data with your updates. Batch size, generally speaking, we don't have to think about too much because the tool will set that to the maximum that your hardware can support. But generally speaking, larger the value, it can process more samples at once and it'll run more quickly. Typically, we don't have to touch that. And if you ever need to, you could also perform a full training as well, and that will totally redo the model based on your new data set. We're not going to sit and wait for that to run now, but essentially it would run through the training process, and I'll start it quick here just so you can see, you confirm your control imagery and your control ground tooth, and then the process goes ahead and kicks off. And this will take a few minutes, so I'm just going to go ahead and cancel it now because we don't need to watch it finish right now. So that's about all I wanted to cover right now. But let's go ahead and wrap up before I run out of time here. If anybody is interested in using the Global Mapper Insight and Learning Engine, anybody who currently has a Global Mapper Pro version 26 license, you should have the Insight and Learning Engine license built right into Global Mapper, and you can go ahead and use it. That built-in license will be valid through the end of February, at which point that'll then get extended or renewed, assuming you update to version 26.1 when that comes out. And if you're in maintenance and support, that shouldn't cost you anything at all. Again, if you have Pro, you can go and look at all of the point cloud analysis tools that I talked about earlier as well. So please feel free and go ahead and take a look at that and get hands-on with that too. So just to wrap up here, Global Mapper now has a variety of AI-powered analysis tools. Those might be the point cloud-based tools with machine learning methods for geometric and semantic segmentation, or in general classification, and then of course the Insight and Learning Engine, where we have deep learning powered image analysis tools. So please go ahead and take a look at those tools and keep an eye out. I'm sure you've already heard today, but we have a release coming up shortly here in the next few weeks, and both of these tool sets will see some updates with that as well. Thank you.
Alrighty, so I'm going to welcome Jeff back for our live Q&A.
Hello.
Hello.
How are you doing today?
Doing well, thank you.
Good.
How are you?
Good, thanks.
I'm glad. Alrighty, so we have someone wondering which versions of the software include the Global Mapper Insight and Learning Engine. I think you covered that in the session, but just for clarification.
Yeah, good question. So we released it with version 26. So that was back in September. So anybody with active maintenance and support of Global Mapper Pro in version 26 will have access. And that will continue now with 26.1 that's coming out in a few weeks as well.
Awesome, thank you so much. And then we have people wondering about if this is in any of our training materials so far. I don't believe it is, but I figure you can answer that.
Yeah, I don't believe it is yet either. We may have touched on it in one of our new What's New courses that's online. But other than that, it's not in our official training yet. We're kind of waiting, since the tool's still in the beta phase, to have it a little more complete before we do that.
That makes a lot of sense. So the next question that we have is someone is wondering if the deep learning tools that you mentioned can provide an accuracy report.
Great question. As of yet, we don't have that exposed or provided. And essentially what we're doing, and I'll use either vehicle detection or building extraction as an example, we set basically a confidence value, and if the tool thinks it is confident enough to call something a building or a car or whatever the case may be, it will then include it in the estimate. What we're looking at doing as we further wrap up the tool is maybe exposing that setting to the user and looking at how maybe some of those values could be added as attributes to the vector feature. So you'll have that information with the tool.
Awesome, thank you.
Mm-hmm.
So what sort of resolution and or other requirements does one have to meet to do manhole detection with the segmentation-based AI methods?
I don't know if that's a point cloud question or an imagery question, If it's point cloud, the answer is as long as you have enough points that represent the feature of a manhole cover, shouldn't be a problem. On the imagery side of things, since we don't have a model trained yet on manhole covers, you would probably fully retrain the vehicle detection model, and you'd want to have high enough resolution such that you could actually see the manhole cover, right? If the manhole cover is 1 pixel, it's not going to work. So I would think anywhere in the range of that, sub-foot resolution that we have the tool using already would be sufficient for that. But again, not something we've officially tested yet.
Cool. Another like resolution-based question that we have is, have you found an ideal pixel size for deep learning imagery? I've found other image deep learning softwares that have trouble with less than 5 centimeter pixel imagery.
That's a really interesting question. And I think initially what we've seen is that depending on the data you're using to train your model and the quality of that data, you have a little bit of flexibility in terms of resolution. However, the big caveat there is what you're trying to find. Buildings, right, are much larger than a manhole cover, for example, right? So you could get away with probably lower resolution in that regard. I wouldn't say that we've found a one size fits all approach, and I don't know if that exists yet in the field of deep learning, but um, I would say that we've seen so far that it can be variable based on the training data, the control data, and what object you're trying to identify.
Great, thank you.
Mhm.
So we've got another question wondering, is it possible to simplify building outlines by reducing the number of vertices to the bare minimum and keeping the interior angles 90 degrees?
Yeah, that's a great question. So that's what the simplify and the regularized settings attempt to do within the running the tool itself. And then we have our own like simplify tool. You could re-simplify outside of the tool itself. Um, but one of the things we're looking at is trying to figure out a way to improve that directly in the tool. Where that gets tricky is, the fidelity to the data compared to what you want your smooth building footprint to look like. So that's one of the things we're looking at now in that regard.
Cool. So does the Insight and Learning Engine allow for using derived input variables like NDVI or combinations of elevation and imagery products?
That's a stellar question. At this point, it does not, but that is something we're actively looking at where, either we or users can provide multiple types of data for the same region in an attempt to more accurately find objects or detect whatever it is they're trying to detect. So that's an active area of research for us.
That's great. So I'm going to wrap it up after this next question, but
Okay.
we've got someone that says the point cloud processing tools look great. How much computing power do they need to utilize it?
That's always the fun question. It varies depending on what the data is you're working with. Um, Obviously, when you're working with very large point counts and file sizes, you're going to start thinking about your memory constraints because these can be memory intensive processes. 32 to 64 gigabytes is never going to be overkill. Generally speaking, the more cores you have on your CPU, the quicker the process will run, or really any process that's multi-threaded. So that's another thing to consider. And we do have, I should say, Meg, we do have that listed in our documentation for recommendations if somebody's concerned with looking at those specifically.
Awesome, that's great. So I think that that actually wraps us up. So Jeff, thank you so much for your presentation and thank you for answering those questions.
Yeah, thank you.
We'll make sure that we get to any questions after the fact, but I hope you have a great day. Thank you so much.
Thank you. Bye.
Up next, we've got Mariah presenting the academic scholarship ceremony.
Hi everyone, my name is Mariah. I'm the Academic Outreach Coordinator here at Blue Marble, and today I'm excited to be acknowledging our academic scholarship recipients for the fall of 2024. The academic programs at Blue Marble Geographics are geared towards educating the future generation of geospatial professionals. We offer accredited institutions access to our software to ensure students become well-versed in professional-grade technology to develop their careers. Every fall, we conduct a scholarship contest where students can apply their knowledge of geospatial technology for a chance to win a monetary award and a free license of our Global Mapper software. And now announcing our scholarship winners. From our undergraduate category, congratulations to Caitlin DeWater from the University of New England. And from our graduate category, congratulations to Mohammed Samam Islam from Western Illinois University. Congratulations to you both, and we wish you luck in your future educational endeavors.
The most fulfilling part of my job by far here at the University of New England is working with our students. We have amazing students who come from around the country to the University of New England to learn, particularly in the marine and environmental sciences. Our students get to work on some of the most amazing environments in Maine. And so our coastal campus students have access to beaches, marshes, woods, the river, estuary, all right on our campus. And so getting to work with students to solve real world spatial problems is extremely rewarding.
Right now I'm working on a project looking at the city of Biddeford, and I'm seeing where all the urban areas are where there are currently trees. So I'm using the tree extraction tool from Global Mapper, and I'm targeting where all the trees currently are and then spaces where they could be implemented as well. So this is through city planning, and then also looking at where there can be more development to plant trees within a city. So using Biddeford as an example for more cities in the future, it's just really cool seeing local use of this technology.
Our academic programs are designed to support the needs of professors and students. We provide free academic licensing for qualified institutions in both the United States and Canada, along with curriculum including labs to use within your classroom and scholarship opportunities for undergraduate and graduate students.
Of course, my favorite thing about the Blue Marble Geographics program is the opportunity that it provides our students. So our students otherwise would not have the opportunity to learn the suite of softwares offered by Blue Marble Geographics, and giving them that exposure to the software that allows our students to both gain new expertise, but also exposes the amazing suite of software that Blue Marble has to new industries and new companies.
All right. Hello, everyone. I hope that you are doing well. Welcome back from lunch. Before we head into our afternoon sessions, I will be sharing some of the upcoming training opportunities for all of the Global Mapper and Geographic Calculator users who want to brush up on their software skills in 2025. So, getting started, if you guys want to know what's new in Global Mapper version 26.1, which will be released soon, we have these two webinars that will be hosted in March. These QR codes can be scanned and you can check them out. So it's a great opportunity. Our technical experts do an amazing job with these webinars, so it's definitely worth checking out. Up next is our online classroom. This is a great platform for users that are just getting started using Global Mapper. And the online classroom is a great online platform that we host. There are free and premium courses that are developed for users of all skill levels. So if you scan this QR code, that'll take you to our online classroom. You can check out the various options. Some of those include the basics of Python in Global Mapper Pro. This course basically provides the foundational knowledge on Python scripting, how to use it in Global Mapper Pro, and just do some basic other things. After that, we have our Principles of Global Mapper Pro scripting course. This course is designed to provide users with a comprehensive understanding of Global Mapper, scripting, and how to automate your tasks and streamline workflows. And I'm very excited to announce the upcoming premium course that we're releasing, which is the Pixels to Points in Global Mapper course in Global Mapper Pro. So definitely check in with us soon to get started on that course. As for our instructor-led trainings, these are great opportunities for businesses, professionals, other mapping enthusiasts. If you want to work in a hands-on environment with instructors, this is the way to do it. So we've got all of our upcoming training schedule right here, and you can sign up for those trainings by heading to that QR code. So check those out. We've got some great ones coming up, including 2 in Australia. So any Australian users, feel free to check those out. As for additional training resources, we have our knowledge base and our YouTube channel. As we've mentioned earlier today, this event will be available on YouTube throughout the month of February, so definitely subscribe there if you're interested in watching these sessions back. And the knowledge base is a great first stop to answer that question that you have about the software. So take advantage of those resources, and that's about it for my training session. So thank you so much.
Okay, I think we are live. So my name is Sam Knight. I'm the Vice President of Product Management here at Blue Marble, and with me today is Scott Weber. Scott is the Product Manager for our GeoCalc calculator and Geographic calculator cloud lines.
Hello, everyone.
So today, this session is going to be focused on one of our newer tools, and that tool is the cloud version of our Geographic calculator software. So calculator has been around for a very long time, and this year we finally unveiled the cloud version of that. It's a new product for us, added on to the what folks may be familiar with in the desktop platform of Geographic calculator. We added this to our line back in November 12th, and it's been out there. Folks are starting to use it. And this is going to be a session where we just talk a little bit about what is in the Geographic Cloud, Geographic Calculator Cloud, exactly how you access it, and all the bits and pieces you might be curious about. As we're going along, feel free to throw in any questions, and I believe Mariah is going to help us out with those at the end. So we're just going to shut off our camera here and get into our slides. So the main thing about Geographic Calculator Cloud is, what is it? What does it do? So it shares the name with our desktop platform. Geographic Calculator is essentially the tool that launched Blue Marble Geographics. So the desktop platform in various incarnations has been around for just about 30 years. It's got a following for the things that it does, and the cloud platform is basically taking the utility of some of those features in the desktop, not everything, and we're going to talk about where those new functions are coming in, taking some of those features and bringing them into the internet so you can access them anywhere in the world through a simple web browser. So the first thing is we say you can use it wherever you have an internet connection. So this is a browser-based tool. It is not, there's nothing to install with this. You simply go to the site of the calculator, and it loads up an interface that shouldn't be shockingly different to folks that are longtime users of the desktop platform. There are some changes, and we'll be kind of highlighting some of those as we talk along through our slides here. The way organization of users works is you basically are assigned a team of folks within your company. This is tied into your desktop licenses at this point. That may change in the future, but your team of users can sign on from any machine with just the order number that you have for your desktop platform at this point. And again, in the future, this may become a standalone offering. But when you are grouped by that order, it works exactly the same way as your desktop platform. By virtue of entering that order number, you are granted access if you have access to that with the purchases you've made. The main tools in the calculator are a subset of what is available in the desktop platform. This is a first iteration, and it will be growing, and we're hard at work right now on adding additional functions to the tool. There are three main areas of actual data conversion work. So all the typical geodetic conversions you might be expecting from the desktop platform. So in the cloud platform, we're calling those of you on the desktop familiarity will recognize the term interactive conversions. In the cloud platform, we're simply calling those point conversions. That's where we have one single numeric coordinate and you're doing some type of operation on that. When we have many of those files, we're talking about tables and spreadsheets, whether those are something common like an Excel sheet or ASCII delimited text, that type of stuff. Those are going to be found on the point file job. And you'll see these represented as tabs across the top of the interface. And then finally, there is the vector file job. And that is also likewise familiar based on what we have in the desktop platform. These three jobs are really sort of the workhorses of the desktop platform. So what we started with in bringing this new code base to the web are the things that have sort of always been the longest, oldest bedrock features from the desktop platform, the ones that folks use day in and day out. This is added on top of our tool that we've had on the web for a number of years now called GeoCalc Online. And GeoCalc Online is basically a web repository, a database of coordinate systems. And it's the geodetic data source, all the parameters of the coordinate systems, transformations, units, ellipsoids, all of the geodetic parameters that live in the background of all the geodetic operations that we do in the desktop platform, in the SDKs, in any of our software. So the foundation of that side of the tool is found in the search tools within Geographic Calculator Cloud. So the search tools effectively replace what we have been hosting on our site as GeoCalc Online. So it is basically superseded and replaced by these tools. The searching abilities to go through the geodetic definitions, we can search in a number of ways. Things like name of a coordinate system or some definition entity. It doesn't have to just be coordinate systems. We can search by locations for things that are assigned locations like transformations, coordinate systems, and so on. Object types. So if you're looking for all of the parameters in the database, we call those objects. You can say look for a coordinate transformation, or you can look for a unit conversion, things like that. And then once you've found those things, you can make those portable. You can either directly link to them, or you can export them as, say, things like well-known text or geographic markup language files for portability to take those into other types of applications.
And the user interface for this search tool in Calculator Cloud is much more user-friendly, interactive design than the desktop version.
Okay, and then some bits just about how the service works itself. In terms of getting at your data, so the files that you're going to play with in this tool. Point conversions are simple numeric conversions, so those don't really need any data access. You simply type that into the coordinate fields for input, and you'll calculate your output. There's no files there. So the main two things are on the point file job and the vector file job. Point files, so this is where we're talking about things like basically spreadsheets of data, tabular structured data. Those can come from your local storage. And what that means is it simply comes from your computer. You upload it into the interface, and you choose what types of operations you're going to be working on, and you do that, and it gives it back to you in your local storage. Now, vector files, on the other hand, those can come from local storage, meaning you upload them just like point files, but you can also access vector files directly from Azure Cloud Storage if you have Azure Web Storage set up for your tables of any type of that vector data. So this is growing. Our first support for this is simply in the Azure cloud space, and we are looking at expanding that into some of the other cloud ecosystems as well. In terms of actually working with the data, spatial data comes in all sizes and shapes. It could be something simple like an Excel sheet with 20 pairs of coordinates on it, very light data, or it could be a gigabyte size vector file that has very heavy attribute tables, lots of finely detailed basically points, lines, and areas. And as such, how we handle those are going to be a little bit different. This does rely on cloud infrastructure to do the work in that type of mode. And there are essentially 3 virtual machine classes that are behind the scenes in here. And it depends on what sort of data you are putting up. If you're putting up something very light, the work might actually take place right in your browser. It never even needs to go to the cloud. If you're doing something a little bit heavier, that's going to start spinning up virtual machines in the background to accommodate that file. And if you're doing something really heavy, it's going to spin up a very rugged, very CPU capable machine in the background to take on those much heavier tasks. So an example of that might be, say you have maybe a seismic layer that's very dense, very broad data, multi-gigabyte file, and you have that stored as a vector file on your Azure cloud storage. That's obviously going to take a much more rigorous process, and that would spin up the largest of the virtual machines in the background to accommodate that file. All of that happens behind the scenes based on the data that you're loading in. It doesn't actually have to be chosen up front. So how we figure out the costs in this, there's basically there's a sort of a formulation of how heavy the data is, how much processing time it takes, the size of the data, the bandwidth for upload and download, all of that sort of thing. That gets distilled down into what we're using inside here it's a credit system specific to this application. So for folks that are a Geographic Calculator user, you are going to have access to 100 free cloud credits per month with your desktop purchase. And it's simply something that it's there, it's available for you to use. You don't have to buy anything extra at this point. And that, again, that may change in the future. There may be some folks that only need access to the cloud portion, and we'll be developing that over time. These are based on annual plans. So if you have, you start using the tool and you realize that this is a very useful thing for your deployment and your geodetic conversion needs, there are plans available that can up that to higher capacities if you're working with lots of heavy data and such, and those can be figured out fairly easily with some normal usage. Basically, you can see what it costs to actually take advantage of the conversions. Within this, there are 2-week evaluations available as well, so anybody can jump right in here, request an eval, and start using the site. The process is basically registering as a Blue Marble user on the website. So if you've done something like downloaded software from us before, or if you've registered with as a website user when licensing the software, if you're maybe part of a network license or something like that, you already have a Blue Marble user account. If you have not purchased anything from us, or if your particular username is not associated with an account here, you just need to register. It's a very simple process, like registering on anybody else's website. And then once you log in, there will be a request trial button. There are things you can do in there without registering, but all of the conversion tools do require you to sign in to get access to that full functionality. Obviously, there are going to be a lot of nuances here based on particular accounts, what company you're working for, and what type of licensing you have, and things like that. So if you have any questions about accessing the software and what is included with your regular calculator desktop purchasing, how you get access to that, feel free to contact our sales team. They'll get you set right up. It's a pretty easy process just to get folks associated with orders and get you on your way with checking out the tools. So let's take a little spin around the interface here. So again, we talked about how there's really effectively 4 places where you can do some work in here. We have the point file conversion, which is what we're looking at here. The point job, you'll see it's laid out a little bit differently than we do things on the desktop. And the reason for that is effective use of space in the browser. This application is set up to scale to many various different size screens. So even including things like tablets or mobile phones. When you are in a very narrow browser, you will see all of these fields and columns stack up vertically on top of each other. And so you have more of a top to bottom style workflow that you might pass through. The general workflow is exactly the same as it is in the desktop. So if you are familiar with setting up a coordinate conversion, involving a datum transformation and units and vertical coordinate systems and any pieces of that, all of the same pieces are going to be found here in this interface. The major difference is that the coordinate transformation box that we usually have right square in the middle of our interface in the desktop platform, you're going to see that down on the bottom left-hand side. So everything relating to your input coordinate system is going to be found on the left there with the source point conversion, all the way down through the datum, the horizontal units, vertical coordinate systems if you've got those in there, and the transformation to your output system, which is going to be over here on the target side, down on the right.
And note that the point job also does forward and inverse calculations, and that selection is found down in the transformation area.
And likewise, so these are all the same functions that we have available on the desktop platform. They're just simply now available to you from a web browser wherever you can take that web browser. So all of the same operations, the same left to right or right to left style workflow, allowing you to go back and forth if you're someone that likes to walk your coordinates left and right, as we hear from some surveyors tell us they like that sort of workflow. All of the same formatting options are available for units, everything from decimal degrees to the complicated formats of where the decimals and spacing don't go where they usually do, and so on. So all in all, it's a fairly simple place to work. The extra piece here that you'll see is that there's this little green area over here on the right where it says we're processing our files. That gives you a readout of everything you're doing. So that will show a list of the files you've converted if you're moving back and forth between tabs here, and so on. In the case of the point file job, it will display your output coordinates up at the top on the right-hand side for the target point here. And then also it's going to put those down in this status box. So that's the point conversion job. And next up, point file conversions. So all the same infrastructure is here again, and what we're talking about is how we set up conversions, more specific to tabularly laid out data. So in this example, we have just a simple Excel sheet, and it has some pairs of latitudes and longitudes in happens to be degrees, minutes, and seconds formats. And this is where you might start noticing a little bit different infrastructure from our desktop platform. Setting the columns for what your data, which is the input latitude, the input longitude, and where your outputs are going to go, and so on. That is done utilizing these drop downs at the top of each of these columns. And just like the desktop platform, any data that you have in there that is, just extra attribution or, whatever you might have in those other fields, all that just comes along for the ride. The only thing we need to actually interact with is where your coordinate columns are. And for those of you not familiar with the calculator, there is no required structure here. So the sheet that we have just happens to have longitude before latitude. They happen to be the first and second columns. They could be located anywhere in a very complex table. And it's not uncommon for folks to have multiple sets of coordinate pairs in different coordinate systems in this type environment. But the simplicity of the job is that anything that is not the operation you're doing just stays right where it is. So if we had multiple sets of coordinates in here, you would simply do whichever you wanted first. In this case, our geodetic latitudes and longitudes are the input for this particular example. We would write those out to another set of columns, and then you can go back and do whatever other operation you want to do and add more columns into the sheet. All of that behaves just like, whoops, I'm scrolling through just accidentally hit the mouse wheel there. The coordinate system selection and all of that works exactly the same on all three of these jobs. And so you're going to notice a number of the familiar labels and things, and those are consistent throughout the application.
And this screenshot is clipping off the bottom of the interface where you have your transformation box, and this single point file job will also do the inverse and forward calculations if needed.
Yeah, I think so. What I just did there was I habitually tried to scroll down using my mouse wheel, and that was activating my slides instead. All right, next up is the vector file conversion job. And again, this is exactly analogous to the vector file conversion job in the desktop platform. You'll notice at the top left there where we upload our file for the conversion, we have that choice right there of whether we're going to be uploading from local data storage or cloud storage. If you do have access to that Azure web storage for your data, obviously the process for connecting to that is just going to involve hooking up your account information to get into that Azure storage. And local files is just going to be a conventional file upload, just like you would use for any other platform. The process here, again, mimics those other jobs. It's a very, very simple place to work. As you load your data in, it's going to give you a readout of the number of features in that particular data set, all the coordinate system information, if it contains if the data itself contains a reference to what those coordinate systems are, it will automatically set your input for you. If it doesn't, then you just set it like you would in the desktop platform with an unknown coordinate system. Source and target does have some helper tools attached to it, just like the desktop platform as well. Because the coordinate system is identified and the spatial extents of it are baked right into that file. When we go to do our transformations, just like in the desktop platform, it's going to narrow down the list of possible transformations to get from your source data to your target data. And then over on the right, again, you'll see the little status field as that will be represented as it's converting, and give you a list of the jobs that you've completed basically as you're going across. Okay, and then so those are the three conversion jobs. And then next up, we'll take a look at some of the interfaces here for the search components. So the search, you'll find at the very top of the interface, there are two links up there. You'll see search distinct from the calculator. So if you click on the calculator tab, that is where you'll find access to those three conversion jobs. The search tool is basically taking you back to the style interface we had in GeoCalc Online, but this being the new platform for that. So the search basically takes place down on the left-hand side. In the search, you can search by things like EPSG codes, remarks, notes, the names of anything. And under the object type filters, you can specify exactly what type of parameters you're looking for. When we get our results, it's going to categorize those things depending on how many results come back, obviously. So this search was for the code 4326, which is a very well-known code for WGS84. And you'll see that it returns both things in the category of geodetic coordinate systems, but it also returns things in the datum transformations category because it is the target of some of those datum transformations or the source of some of those datum transformations. So we can expand down into those lists and drill all the way into the actual definitions where we can go further yet all the way inside and get at all the parameters. So again, just like the desktop platform, nothing in here is a black box. There are a few transformations and things like that that use extra grid files, but anything that is a mathematical parameter, projections, datum transformations, and so on, All of those things can be fully researched, fully exposed in the interface. And from that last step, once you're actually looking at these different things, you can take the step to export those as things like WKT or GML files. Any of the entities in here that have spatial extents attached to them, you'll see this is obviously a worldwide system, so you're going to see our red box on the map covering the entire globe. If you're looking at something smaller and regional, it will give you the representations of exactly where those particular parameters happen to live on the planet, and so on. So a number of fairly flexible tools in here allowing you to make the utility of the geographic calculator portable to you. So just to wrap this up and bring it all together, this basically allows you access to the geographic calculator from any computer wherever you've got an internet connection. No downloadable software. It is simply all right in your browser. The main thrust of this is individual points, point files, so spreadsheets and vector files, plus the ability to access the full data source and browse through all of those parameters as well. Everything is cloud hosted. The database lives in the cloud of all of those systems. It is basically our primary source for publishing those for access in any of our software. You can get to your data both either locally from your local device, whatever that is, or directly from Azure cloud storage. And this is available to anyone that is a licensed user of the Geographic Calculator. And I think that about wraps us up right on time. And I believe Mariah is going to come on and help us with some questions.
Yes, hi. Thank you, Sam and Scott, for that overview of Geographic Calculator Cloud. And we can definitely kick off the Q&A session now. As a reminder to folks, we encourage you to ask questions. You'll be automatically entered for a chance to win a free license of Geographic Calculator. So let's start with the first question. You did go over this just at the end there, but as clarification, is Geographic Calculator Cloud licensed separately from Global Mapper Pro?
Yes, that is a separate product. The access to the cloud tools is available to specifically Geographic Calculator users at this point. Anybody that is a Global Mapper user is very welcome to complete a trial, and we would love to have folks do that.
Mm-hmm. Our next question, does Geographic Calculator or Geographic Calculator Cloud do grid to ground or ground to grid conversions?
So the coordinate conversions that we do in here are basically out of the geodetic data set that we have. So that's the collection of projections, geographic systems, some particular string-based coordinate systems, things like the Alberta Township system and so on. All of these systems are geodetically based. So for folks that are working with what we call best fit grids that are truly ground coordinate systems, that's not something we're going to find in here yet. But within the calculations of point files and the individual point conversions, the utilities are there to do those grid to ground calculations. So things like scale factors, convergences, and so on. So all of the same types of outputs that we have in the desktop platform are going to be available on the web platform. So some of the coordinate systems that are more of the custom user-entered, truly ground systems are yet to come in.
And we're going to be hearing a little bit about grid to ground work in our next presentation, I believe.
Yes.
Great, yeah. Our next question, is there support for the new state plan low distortion projections?
Okay, I don't think we've had a web session in the last 5 years where that question has not come up. It is the hot topic. So the new state plane coordinate systems, for those of you in other countries, within the next year, the United States is going to be getting a new set of state-by-state coordinate systems, and this will be replacing our current national standards. So every state is going to have new coordinate systems. Every state is going to have one statewide coverage. There's going to be a number of smaller zones in there. And then also there's going to be nearly full coverage of what we call low distortion projections, which are very localized and very, very low distortion from those types of grid to ground measurements. Those are currently in development by the National Geodetics Survey. This is, and I always joke that this has been a question that comes up for years because this is a very long project. It initially began as a 10-year project under NGS. They call it the National NSRS Modernization. And the outcome of that we're hoping to see at the end of this year. So while the new coordinate systems are not yet published, they don't exist as a standard yet, for years and years, we have been doing the preparation to be able to support those as soon as they are available. And that goes up to and including testing the individual zones in their provisional definitions as they exist now. I would say it's probably very likely that the person asking that question is familiar with the provisional publication of those on the NGS's beta website. And this represents about 1,000 new coordinate systems that will be joining our database, hopefully this year. While we don't put the provisional definitions in the software, basically to avoid confusion, we don't want there to be any room for errors from folks using incorrect parameters that may change this year. We are waiting to publish those when they are actually an official standard. We are basically lying in wait. As soon as they are published, we can most likely have them imported and available in about 5 minutes. Scott and I have been working on this for a long time. You got anything to add on this one?
Well, I was going to say that if you're interested in the method that the NSRS modernization low distortion projections are performed, I put together a 7 or 8 minute overview video that you can find on our YouTube channel, very quickly going over the whole procedure that they've implemented for creating these low distortion projections.
Mm-hmm. Great. Our next question is, how is the cloud storage security protected?
So the cloud, everything that happens on our side is set up with basically with secure procedures. Everything is authenticated based on basically secure processes for your user account in the same way that your account is protected with your regular website account here. When we interface with Azure Cloud Storage, accessing your data that is in other cloud storage, that all basically uses the same user access keys that you would use to basically log into that system elsewhere. So it is all done with current best practices and so on. Any of the data that is entered in that is processed purely locally, it actually never even goes to the cloud. So there are a number of things that happen right in the browser, and the only data that does go to the cloud are those heavier things like vector files at this point.
And there's Azure has certain architectures that help ensure security, separating different functions from each other, and we're incorporating those.
Right. Okay, I will wrap it up after this last question. Have you worked with any of the states that have already switched to LDP, like Kansas?
Yes. So over the years, low distortion projections are not really new anymore. We've had them in there for a long time. So Kansas is actually one of the more recent states. I'm thinking of one I remember off the top of my head is Iowa. We actually directly worked with some folks that were vetting the parameters that they came up with to make sure that they were compatible with software. And I know those folks reached out to a number of different companies to work with. We did testing for that. We've been testing for all of the new standards. So we've actually loaded and verified every provisional publication of the new low distortion projections, well, all of them, not even just the low distortion projections for the coming state planes. But states like, say, Minnesota, Wisconsin, some of the states that have had very long-standing low distortion projections, Oregon is another. We've had direct contact with many of those folks, and a lot of those are very mature coordinate systems. They're well established, and we've supported them for a very long time now.
And while low distortion projections aren't new in and of themselves, the method used for all of the NSRS 2022 projections, they all follow the same procedure, and it's more portable than some of the traditional methods that have been used in the past.
Great. Well, I think that's all the time we have for. Of course, we'd love to ask you more questions, but thank you again so much for that presentation.
Okay,
Next,
thank
we
you.
will be hearing from Alonzo de la Cruz about how Suncor Energy utilizes Geographic Calculator to enhance their workflows. So excited to hear that one.
Welcome everyone, my name is Alonzo de la Cruz and I'm the Senior Geomax Engineer for Suncor Energy here in Canada. Today's talk is going to be the evolution of our custom coordinate systems in Geographic Calculator. First, a little bit about me. I've been with Suncor since 2012, and before that, I was in the field for a little bit. But at Suncor, one of my main responsibilities is to deal with any coordinate system and transformation issues that pop up. But an interesting fact is, with our custom coordinate systems, most of those were created before I even started. So something called living with history, living with those past decisions is required. And you'll see. So which area of the world are we talking about? Well, the project areas with our custom coordinate systems are in northern Alberta. Specifically, they're just north of a town called Fort McMurray. So you can look that up if you like to get a better idea. And each of these project areas, so each of those squares or rectangles that you see there, has at least whatever you want to call it. Custom coordinate system, plant grid, mining grid, engineering grid, local projection, you name it. It has at least one of those. And the reason we use them is that they're actually really useful and important at Suncor for the things we do. And I'll explain why. So let's look first at this orange rectangle here. This area here, you see this plant. This is one of our oldest plants at Suncor, if not the oldest. We call it the base plant. And it has a very unique custom coordinate system because it's one of the first ever created for our company. And it's so old, it's from the 50s and 60s, that it's from before Canada adopted the metric system. So it's actually in feet, which makes it quite unique. And you'll see why we built it. Let me explain why we use these custom coordinate systems in general. First, the numbers are smaller. I want you to think back to the 1950s, 1960s, what work was like back then, especially for surveying, construction, a lot of this geospatial work. You didn't have computers, less likely a digital calculator. You didn't have GNSS. A lot of surveying was still done with chains back in those days. So you needed a coordinate system that fit the area that you were working with. That was essentially localized to the area. It needed, in this case, it was oriented to fit the direction of the river. Its numbers are smaller. The false easting and false northing are in the tens of thousands, rather than with a UTM zone in this area has the northing in the millions and the false easting in the hundreds of thousands. With less digits, less likely you're going to make an error, easier calculations. And finally, a scale factor was chosen that fits the ground in this area. So what that means is a unit of measurement in the custom coordinate system or in the plant grid matches a unit of measurement on the ground. So essentially a foot in the grid is basically a foot on the ground. And so what happens if we say reproject this image that's projected right now in UTM zone 12 to the plant grid? You get this. Now all of a sudden you can see the layout of the plant grid. It makes a lot more sense. It's laid out essentially north-south. You can see how it lines up to the river. That's why they created it. Imagine if you had to account for that 30-ish degree rotation off north in every single one of your calculations as you're trying to lay this out. Didn't make a lot of sense. So that's why we create those plant grids in the past. And even now, with the computers and everything that we have, that scale factor is still necessary so that a unit of measurement in the grid matches a unit of measurement on the ground. And with some of these older ones, especially older custom coordinate systems, they have unique characteristics that can cause issues in other software. But coordinates in general can be a little complicated. See, with our work, because what we do is physical, we build on the ground, we extract the physical resource, we have all kinds of professionals and teams using geospatial data, and they aren't necessarily geospatial professionals. So things like datums, projections, elevations can be a little tricky. That's why we need Geographic Calculator, and that's why it evolved over time, because it's easy to use and it does basically everything that we need it to do. Now, before we jump to 2015, let me explain what happened when I started at Suncor. Calculator was being used before I even started in 2012, but when I started, it was very niche. There's only a handful of people that could use it, because while it did quite a bit, it didn't do everything we needed it to do. But in 2015, Blue Marble added an extremely useful format to both Global Mapper and Geographic Calculator. And to get an idea of what else was happening in 2015, Uptown Funk was the #1 song in North America, and Force Awakens was the top movie. So while you were singing along with Bruno Mars and cheering on Han and Chewie, we were celebrating Blue Marble grids as they hit the scene. That's right, Blue Marble grids allowed us to do everything we wanted to do in Calculator, because Blue Marble grids made the more complicated vertical conversions possible in Geographic Calculator. See, some of those older custom coordinate systems had a vertical component that was pretty tricky, because it wasn't a simple offset, and it wasn't a simple offset and slope. It was a little more complicated than that. And we had trouble customizing Calculator until the grids came out. And once the grids came out, then all of a sudden we could do 3D conversions for everything at Suncor. So let's take a look at that area again. Let's take a look at these two, that orange, the base plant, and the red square, the base mine. The first two grids we built were for that. Here's the one grid. This grid goes from CGVD 28, Canadian Geodetic Vertical Datum of 1928, which we still use, to that base mine, so the red square. This one, you can see how it slopes in a different direction. This one goes from CGVD 28 to the base plant. And finally, this one goes from base mine to base plant. Now, you'll notice something about them. They're quite massive. Why did I make the grid so big? They do seem way too big, because we've learned a very hard lesson over the years, and it's an undefeated rule when it comes to custom coordinate systems. They will always be used beyond their original intended area. It does not matter. I want you to think about our company. We have thousands of employees across North America doing all kinds of work with geospatial data that's in these custom systems. We can't police it. There's no magical boundary where we have to tell people they can no longer use these coordinate systems. So rather than being a bottleneck or trying to do the futile work of trying to police that, we have a different philosophy. We'd rather make it easier so that they can do any work that covers any reasonable scenario with those custom coordinate systems, so that they'll never come across a situation where they're trying to do a full 3D conversion and the grid doesn't cover it. That's why we made them so big. How do you make them? Well, pretty straightforward. First, you have to make a custom vertical datum. And second, you go to the transformations in your data source. You go to vertical, you click the plus button. See all those blue ones? Those are all the custom ones, all the custom transformations we've made. It brings up the dialog box. You give it the identifiers are name, code, etc. And in details, this is important. First, your source and target has to be right. You have to know from what's your source datum and what's your target datum, because your Blue Marble grid is also in that order. The delta z's are in that order. Second, your vertical offset file. You'll notice the vertical transform is Blue Marble vertical transform grid. You have to select that. So that brings up these parameters. You have your vertical offset file. That's the Blue Marble grid file that you make in Global Mapper. You give it whatever name, its format is .bgd. And lastly, the path. You can put this the Blue Marble grid, in any folder that the computer can read or the software can reach. What's really useful about that is it allows us to make any changes and updates to these grids without the user having to do anything on their end, because it'll just keep functioning the way they want it to. We can just add the new grids or replace the old grids as needed. And their Blue Marble grids are super easy to make. In Global Mapper, you need to upload what's essentially an XYZ file. But rather than Z being the elevation, it's the delta Z. It's that difference from the source datum to the target datum. With positive means the change is going up, negative means change is going down. You import as a grid and you export it as a Blue Marble grid. And these grids now allow us to do transformations of all kinds of data in Calculator and Global Mapper. That's why they're so useful. And this is one of the reasons why Geographic Calculator has evolved in its use and popularity at our company over the years. What started as a handful of people using it prior to 2015 has now grown relatively company-wide because it can do everything they needed to do coordinate transformation-wise. But the evolution of Calculator didn't just end there with the vertical grids in 2015. There's been other things to help make it more popular over the years. Fitted systems. If you have to deal with custom coordinate systems, fitted systems are so useful, and they've really evolved over the years at our company. Here's just the list of the fitted systems we use, and we essentially make one for every one of those areas, those project areas I showed you earlier. And the reason they've evolved over the years, and the reason we make them, is this: they work exceptionally well on lists of 2D coordinates and CAD files. See, the beauty of fitted systems is that if you have the data, that transformation using the fitted system can be more accurate than going through a projection, especially for some of these older local plant grids, these older custom coordinate systems. Sometimes the projection is only accurate to that centimeter, decimeter level. But if you have the right data with the fitted system, that transformation is essentially at the millimeter, sub-millimeter level, thus eliminating any error in the coordinate conversion itself. That's why they're so useful for lists of 2D coordinates and CAD files. A little bit of history. Before I started in 2012, the company actually got Blue Marble to make our first 4 fitted systems. They gave them a list of control points, and each of those areas that you see on the screen represent the area covered by those control points. And they actually were really good. But over the years, we've expanded the area of the control points, increased the density of the points in the fitted system that we used, and thus we're able to increase the order of the polynomial so that it would be even more accurate. And fitted systems are useful in the following 2 scenarios. This is where they really shine. For those older coordinate systems, where the projection, so the conversion through the projection has an accuracy at the centimeter, decimeter level. And what you want is a conversion at that millimeter, sub-millimeter level. See, depending on where you're using the data, the projection might start to lose some of that accuracy. So this is where fitted systems work really well, because they give you that expected conversion. And when you're almost exclusively just going between 2 coordinate systems, this has come up a lot lately, especially from a geographic or geodetic, so from a lat long to a custom system. They're great because you can just bypass going through a datum conversion or anything like that. You just create a straight conversion between the 2, thus giving you the exact conversion that you want. That's where fitted really shines. That's one of the really important uses of Calculator at Suncor. And here's a useful tip for you. 2-point fit projections are great when you have very little data. There's been a couple projects where we had almost no data to work with. We're talking a minimal number of points. And the 2-point fit projections worked really well to help us solve those issues. Let me explain. Here, let me show you a real case example of one that popped up for us. Again, look at the units, feet. So we're dealing with an old one, and we had almost no data for it. In fact, all I really had to work with was a control plan with 5 points attached to it. But they're super useful because, first, you only need 2 points. All you need is your easting and northing and lat long for 2 points. That's it, which makes them real easy to make. Second, they're really accurate. Calculator essentially takes care of the orientation, the scale, and the translation for you. So if you have very little data to work with and you need to make a projection that you can then use to export the data out into a more common projection or coordinate system, that's where they really shine. The only drawback is, as far as I know, they can only be used in Blue Marble products. So you can only use these in Calculator and Global Mapper. Yeah, I kid you not, when I said all I had was a control plan with 5 points, this is essentially how the points looked. And what you do is, you essentially use the 2 points that are farthest apart diagonally. This way, having that longest length takes care of any issues in your scale, your orientation, your translation to make it really accurate. So if you ever have to deal with something that you have super little data with, a custom coordinate system that's really old, 2-point fit can really save you. Now, GeoCalc mode in GlobalMapper is what made Calculator really important company-wide. A lot of people use GlobalMapper at our company. But the reason is not just because of all the formats that GlobalMapper can handle, but because through GeoCalc mode, it can read all our custom coordinate systems and transformations in full 3D. See, everyone who gets an install of GlobalMapper also gets Calculator so that they can use the Calculator library. You just turn on that button and it brings up everything that it's almost everything that you've made in Calculator. So here for a horizontal coordinate system, if you need to choose one of the custom ones, you click on the button there, and here you can see the list. And now it brings up the geodetic and the projected. Luckily, the projected are in blue. Anything you've created is in blue. For vertical, they're there as well. It brings up all the vertical systems, again, in blue, so that you can find the stuff that you created. And finally, the transformations. It brings up not just the transformations that you made, but also it can generate two-step transformations to bring in data using the Calculator library. And not just it for horizontal, but it does the vertical conversions as well, using those blue marble grids that we created earlier. So there are two key events that really took Calculator from a niche product that only a handful of us used when I first started in 2012 to being much more widely used, not just by geospatial professionals, but by non-geospatial professionals as well. One, when we could do the full 3D coordinate conversions. See, once we could do everything, Calculator is a nice software to teach to almost anyone because it's easy to learn to do the conversions. And two, when Global Mapper was acquired and the GeoCalc mode was implemented. So it meant that that Calculator library of custom coordinate systems and transformations was available in Global Mapper. These two events are what took Calculator from a niche product to much more widely used. All right, thank you for listening. I'll answer any questions now. In case you want, you can find me on LinkedIn here. Thank you very much.
Hey there, Alonzo.
Hey.
All right,
Can you hear me?
Yeah, we got you.
All right.
That was great. So man, that was like a blast from the past for me. As you were saying, we started with 4. I looked at Scott and I was like, yeah, I did those.
Yeah. I was saying you were the one who made them. Yeah.
Yeah, it's neat to see the evolution of those throughout the years. I definitely remember, when we had some of the initial data that you were putting together for the vertical systems, and then seeing that it's grown to the point where it's all unified is really really neat. So in the development of those, I think one thing people looking at this from outside might be interested in is what was the lift in actually assembling the vertical control to spread over that wide area? Like how long did you have to have surveyors out in the field
Oh,
doing that type of collection?
so we didn't, obviously we couldn't survey every single point in the grid. It was a massive grid. We did at 10 spaces each, but there were these formulas, hard formulas that we had to follow, that essentially were gospel, that we used to build the original grids, the big massive grids, and all the survey control was actually used as our check. That's how we were able to check whether it worked or not, is that then we had actual survey data that we could trust, say, whoa, the grids are good within this much. The original ones were a couple centimeters, a few centimeters. Now we got it down to the millimeter level. But yeah, so we couldn't survey every single point along that, but we did have quite a bit of control that we could use as our check. But the formulas is what we used to actually build the CSVs.
Yep. And so you've also, I mean, in the time, going all the way back to 2012 and coming up through to now, you've brought these through, different realizations of NAD83 and things like that, presumably as well. How was that for you?
uh, it wasn't too bad. Yeah, there have been different realizations in NAD83. So I would say, in each time we did, either we made a different fitted system, or oftentimes what we'll do, it'll be the double transformation, where if you're going from one to the other, like say from an old one to some current one like NAD83 CSRS, it'll be that double transformation that we actually built a custom transformation, just taking care of it so a person can select it. They just find the name where already the concatenated, I believe it's called, concatenated transformation is already there, that they don't have to try and figure it out. They just basically look for the name that they always look for, so that they can select it. That's usually how we deal with it. We'll do the double.
Yep, that makes a lot of sense. I've seen folks try and do that both ways, and sometimes, they readjust all of the controls and refactor to fit, and that sometimes there's good reasons for both.
Yeah, I'm sure we'll have to do some, especially with the new NatRef 2022 coming out. I'm sure there'll be massive resurveys in the coming year or two of all our control to get, to essentially update everything again.
Is there, I guess, with that I guess particularly for the geoid, since we're going to have the new North American geoid, we're not going to be talking about CGBD anymore and NAVD88. It's going to be just one for all of the countries on the continent here, all the islands as well. Are you forecasting that you're going to be reworking that vertical, or is there any reason to? Maintain it?
So what happens is, like I said, with the living with history part, there's going to be a certain amount of people and a certain amount of data that they're going to have to work in the old system. So we have to maintain the old stuff for sure. As we resurvey everything and get the new geoid values, essentially we're going to have to create everything relatively new. Perhaps the old custom coordinate systems, put in a new datum. Same, maybe adjust the verticals if we have to. We'll try and keep the numbers as close as possible to the previous ones, but essentially we're going to have, like, you will add 1,000 coordinate systems. We will essentially be doubling whatever number of custom coordinate system transformations we have. We'll be adding essentially duplicates of those that cover the new geoid, the new datum, etc. But we'll see after we've actually done our groundwork, our surveys, to see kind of what actually is happening on the ground.
Yeah, I have to admit I'm less familiar with the projection side of things in Canada. Scott and I are all over the ones for the U.S. and we've probably paid a little less attention. Is there a similar effort for provincial projections, or are you gonna is the intent to continue using things like MTM and UTM?
There'll be, so theoretically, the provinces here are obligated to also update their data, their projections, their transformations. I believe they have until 2030 So we'll see when our side. So on our side, for Canada, it's called Natural Resources Canada, and our CAN, they'll be essentially, we'll get our data from them, and the provinces, all the provinces have their own geodetic people. They'll then take that data to essentially rework all that. And then once all that's ready, then is when we can start working off of that.
Oh, so that's neat. That's a very different process than it has been here. Is the organization so that basically the edict comes from NRCan, and then are the provinces are responsible for their own, or is it more top-down control than that?
So without speaking too much, from what I understand, essentially the provinces are responsible for their own. They'll figure it out on their own. So essentially they will work, obviously they work together, but when we go for provincial data, yeah, go to the province. Yeah, don't
Down
necessarily
here,
quote me on that.
yeah. Down here, it's fairly similar. So the NGS came up with the standards and handed the standards off to the state, and then said the various stakeholders in those states. And the sort of interesting part of how it works here is that it's not just the state governmental authorities. It was defined, I forget the term they used, but it was basically interested parties like the state survey associations and things like that. Whatever, they have various names in all the different states. Those groups of stakeholders had to work together to come up with standards and then submit them back to the NGS to say, this is what we want, is this okay? And they're all in the middle of their vetting process right now for that down here.
There probably was something very similar here to some extent.
So I guess for these systems, like living with history is a great way of putting that, because I mean, really the entire database is, you find things from the 1800s sometimes and things like that. They pop up, all the different ellipsoids used in all different pockets of the world. Every part of the world has its own sort of unique pieces. And you mentioned, there are groups that are going to have to stay working in the old system. They're just simply going to be orphaned out there. Is there do you have any ability to can you pull out your crystal ball and gaze into the future and see, is there going to be a point where those local systems stop being important to you?
It'll probably be something similar. It won't be it's hard to say an exact date. What we'll have to, in general, what the general idea will be is, going forward, we'll be in the new systems, finish up as much any work you have to in the old, and then just move to the new systems as quickly as possible, so that one, you don't want to interfere with and mess up ongoing work, but so that there is a little bit of transition time that people can work with. To say when exactly, hard to say. I mean, it's at some point we stopped using NAD 27 here when there was a NAD 83 project to go to NAD 83. So it seems something similar. There'll be some time period where you'll see a mix of both, but then going forward, it'll be the new stuff.
Yeah, that's we've all got to muddle our own way through and figure out where it goes. But that's just I love getting the updates on these. For those of you folks watching at home, I've seen Alonzo give versions of this talk over the years as the systems have evolved, and it is as fascinating for me today as it was in 2012. So I guess thank you very much, Alonzo, for putting this together. It was really really cool presentation.
Thank you.
All right, and so with this question session wrapped up, we're going to be moving on to our next session. In our next session, Detective Eugene Gallant and Captain Jason Burke of the Windham, Maine Police Department are sharing their work on digitally reconstructing crime and crash sites with Global Mapper Pro. So thank you for joining us today, and welcome, officers.
My name is Detective Gene Gallant. I'm a detective with the Windham, Maine Police Department. Together with Captain Jason Burke, we run the crash reconstruction program here for Windham. And as part of that program, along with crash reconstruction, we also do forensic mapping. I have been a crash reconstructionist since 2005, and I've been a forensic mapper since 2006. In 2018, we made the decision to pivot away from our total station for mapping crash and crime scenes and look into UAV technology. We were actually the first municipal department in the state of Maine to start a UAV or a drone program. And at the time, our primary focus for starting the program was for mapping crash and crime scenes. Since that's happened, we've really expanded the program. We went from one drone to now we have 5 for a variety of purposes, not only mapping crash and crime scenes, but also looking for missing people, looking for fugitives, overwatch at critical scenes, things of that nature. So we currently have 2 DJI M30T thermal equipped drones, 2 Mavic Pros, and Nevada 2, which we just bought for interior work. But the program still mainly focuses on, excuse me, mapping crime scenes and crash scenes. That's what we use the majority of it for. And that's what we're going to work on today. So what I'm going to do is I'm going to walk through what a typical workflow looks like for us when we're mapping a crash scene, and actually have a scene that Captain Burke is working on, is actually reconstructing. Crash happened a couple weeks ago that the driver was seriously injured in. Fairly simple crash, but it'll show like I said, what a typical workflow looks like for us. So I'm going to walk through the beginning of it, and then Captain Burke will come in and he'll show you what the post-processing looks like. So pretty simple workflow really for us. We just open up the Pixels to Point program and go get my images. I think I've got it right here. Yep. So with this crash, I did the photos after the fact. So typically I do all my photos, or almost all my photos, using the drone. Just the cameras on them are so good now that I can do almost all my scene photos along with the photos that I'm going to use for my mapping with the UAV. But in this case, I just did my mapping photos, so I don't have to pick through these photos at all. I know they're all what I'm going to use for my mapping. Here. So the main thing that we're looking for out of photogrammetry is right here, the ortho image. Just gonna do the ortho image is what we use mainly for all of our post-processing. It'll have our positioning files, so we can get our basic measurements out of it. Although that's mainly what we use, we still do a point cloud and a mesh. And this is essentially the what you see clicked off here is what the general settings that we use. As far as incremental versus global, sometimes I'll play with that if the scene's not processing the way I want it to, but generally I'll use the incremental setting and then just go ahead and run this. And then once it's done, I'll export the ortho image as a raster image. If I want to use another program to do some more intense post-processing, whether it be getting angles for a 360 momentum crash or angles for rotational speed loss, something like that. So real basic. That's kind of the quick and dirty of how we do our processing of the photographs for an aerial map. And I'm going to turn it over to Captain Burke, and he'll walk through what we do for post-processing, extracting measurements, and things of that nature.
Hello, everyone. My name is Jason Burke. I'm a captain with the Windham Police Department. I've been with the department since 2005, and I've been a crash reconstructionist since 2010. I just became a forensic mapper in 2007, and like Detective Gallant said, we switched over in 2018 to almost an exclusive UAV model of forensic mapping, and so far it's worked out very well for us. Detective Gallant went over the workflow from when he imports the pictures and generates the ortho image along with the mesh and the point cloud. Now that that's been completed, I'll take you through how I prepare a forensic mapping in Global Mapper exclusively. There is another program that we use if we have to gather angles or stuff like that. I think he mentioned that briefly, but this is kind of the basic scene for us. So what I'll do is once the image is finished processing, I'll take a quick look at the overall picture and make sure that it got all of the boundaries of the scene that I need. The general settings that he used in order to build the scene is generally what works well for us, and it's fast and it's accurate. So once I have this image, this right here is the ortho image. I will zoom into the scene and make sure that I can see the ortho image details, and I'll scroll. What I'm looking for in particular is the ground targets. We lay ground targets in on the pavement so that when we are asked if this is a true and accurate representation of the scene, we can say, yes, we laid the ground targets on the ground at a specified distance, and I can verify those measurements using the measurement tool in Global Mapper. So for this particular measurement, you can see that it was 18.8 feet. That's consistent with the measurement that Detective Gallant and I typically lay down on a scene. So I'll save that. I'll put it in existing layer, a new layer. What I typically do is just measure those as, or describe those as just a measurement. And then I'll scroll out a bit, and I'll go over to the second set of ground targets that we have. And I'll do the same thing. I'll do a measurement. And I'll save the measurement. That one's 18.7 feet, again consistent with what we typically do. And I don't have to create a new layer because that was already done. So I will save it And then when we finish up, I'll go through and I'll change fonts and sizing of fonts in order to make sure that the end result is visible on a sheet of paper when we print it out for the DA's office. So once I have those two measurements, you can see them on the screen there. And the second thing that I'll do is I will go through and find my markings on the pavement indicating the crash scene marks. So in this particular instance, you can see right here, there's an orange mark on the pavement, which indicates where the a skid mark is. And then if I go a little further down the scene, there should be another mark on the pavement, which is right here. And that indicates where the vehicle hit the tree, which is right here. So now that I know that I have those two markings on the drawing, I know that the scene is adequate for processing on the computer. As an aside, another thing that I'll do is I'll shut off the Earth image and I'll open the point cloud and see what the resolution is on that. We don't use the point cloud a whole lot because the resolution doesn't always come in that great. This one's fairly decent. I could work with this. The point cloud is generated so that if another entity such as the state police or if a private reconstruction comes in and uses a 3D scanner that generates a point cloud, they can take our data and they can import it into their scene to make a bigger picture or a resolution that has a higher pixel count. I'll also check the mesh, and generally while I am looking at the mesh, I will also look at the 3D picture of the scene. And this gives us an idea of what the road character looked like. In most cases, it'll give you an idea of where the utility poles are located. It'll also show us the tree canopy, debris in the road, and we can also zoom in and we can see how the vehicle left the road and struck the tree. There's the two ground targets. It's a pretty good way to accurately depict the scene, and the 3D modeling creates an experience for the end user so that they can see what the topography looked like, what the actual scene looked like, because sometimes you just can't get those details in that mental picture from a top-down 2D picture. So now that I have that, and I have those measurements, and I have the scene the way it was intended to look, I can go in and do the same thing with my measurement tool. I can scroll in. Let me switch to the ortho. I can scroll in and I can look for that mark on the pavement indicating where the vehicle went off the road, which is right there. So I have the measurement tool already selected. So I'll mark down my point here on the edge of the pavement, and I can scroll out just a little bit and then move my screen so I can see more of the picture. And I know that the tree was right about there, You can also, if you look at the picture overall, you can kind of see the path of travel of the vehicle as it went off the road. But the tree was, the base of the tree was right here. So I'm going to click there, and then right click, and save the measurement. And I know that now that I know that was 55.9 feet. Save that under user created features, and I'm going to hit OK. So there's that. So once I hit my home button, that will show me an overall picture of where my measurements are. It'll create the scene. And I know by looking at that the font is the wrong color, particularly for that northern measurement for the ground target, as well as the northern measurement for the actual vehicle traveling off the road. So I will right click on that setting. I'm sorry, that's not what I wanted to do. I just select the pencil. And then I can select the line. I can right click on it and I can edit the line feature. It is here that I will go to feature style, and I will select the label font. And in this particular case, I think 18 will be a good size for it. And because of the placement, I'm going to change the color to white and give that a shot and see how it looks. Since that's the most important measurement for this particular crash, I'm going to leave that as the big font, and I will go in and do the same for the measurement here. Again, I make sure that my pencil's selected so I can select the line, and then I can right click on it, edit line feature, specify style, label font. I'll keep that a little smaller, probably 12. And because of where it is on the picture, I'll do a white font color. Hit escape to deselect the line, and then I can scroll out and all of it is visible. So this is a basic picture that I need, and I can move into post-processing now, which to me means that I can prepare it as a document that has all of the scale on it. It has the compass rose. It'll have a short description of the location, date of the crash, case number. So I'll move to that real quick. This is the basic map layout editor, and it's here where I can right click and I can insert my north arrow. For this one, I prefer like the compass rose, and I can move that down to a corner that's not being occupied, and I will insert a scale bar. I always use the automatic, seems to work the best. And then I'll also insert a text element. And in this text, I will write date of crash. The location. I'll put that up in the corner where it's out of the way on a blank space. The other thing that I like to do, I'm not sure if Detective Glant does the same thing, but I will go to Properties and I will turn on a grid frame, and I use the Latin long. And for spacing, I play with the spacing just a bit because sometimes the scenes are real short, sometimes they're real long, and the grid frame doesn't always show up. So I'll just play with it a little bit and try and determine what will look best. So for this one, you can see that the grid is really close together and it's not visible. So I'll go into Properties again and I'll change the arc degrees. Because not every scene is the same. Sometimes they have to be messed around with just a bit. So that one came out a lot better. And what this does is it just gives a frame of reference where on the Earth is this crash. You can take those coordinates and you can type them into any mapping software, and it'll take you right to this crash. And that is the finished product. That's what I typically do for a crash like this.
Alrighty. I am excited to welcome the Windham Police Department for a live Q&A. Welcome, Jason and Eugene. Thank you for joining us today.
You're welcome. Glad to be here.
Thank you.
So thank you for that awesome presentation. That was fantastic. We have some questions coming in from the audience. I'm going to remind the audience that anybody who asks questions for this session will be entered to win a license of Global Mapper Pro. So definitely send your questions in and let's get started. So the first question that we have is, apart from accident reconstruction, is Global Mapper used in any other application with the Windham Police Department, like crime analysis or anything like that?
Yeah, no matter, I've used it for both crash and crime scenes. So before with our total station and now with our drones, we use it in not just crashes, but any crime scene where we can use the drone and use the photogrammetry. Works good for all those applications. Sometimes even better. I can think of an example. We had a shooting scene a couple years ago that was outside, and it was over a very large area, so it would have taken quite a long time to do hand measurements with that. So the drone was used, and the photogrammetry software was used to create the map for that, the crime scene map for that.
Awesome. Thank you so much. So we've got another question asking about your specific process for what you do when you get on site to take the photos to use the drone.
So what we typically do is when we arrive on scene, we talk with the investigating officer, any witnesses that might be there, and then we'll shuffle vehicles around on the scene. Typically, fire department, volunteer firefighters will have them move their vehicles so we can get a clean scene. And then we'll put the UAV up in the air. We typically fly with good conditions and no tree cover. We'll typically fly somewhere around 150, 100 feet in that area, and we take pictures I'd say every 2.5 seconds or so to provide the adequate overlap that the pixels to point needs to get a good picture.
And that varies too on the type of scene. So if we're flying lower, I could think of an instance where I was flying a scene on a dirt road that was a lot of tree cover, so I had to fly under the trees. So obviously need more overlap, need a lot more pictures. So sometimes it can be a little trial and error as far as the actual taking of the pictures and flying the drone and seeing what works depending on the actual scene.
Yeah, I actually have a related question based on what you just said. We've got someone that's wondering how often you guys use the drone service to do this kind of analysis. And I'm wondering how that kind of fits in with not having the ability to fly over the trees and things like that. So how often do you fly these drones?
More and more every year. I think the first couple of years when we first started the program, I think our deployments were, somewhere in the high teens, low 20s. And for instance, every year we have to submit a report to the Maine Criminal Justice Academy about our drone usage. And just me alone last year, I had 41 or 42 deployments. And that's up from 30 or 31 last year. And I think Captain Burke would probably have the same experience. Just it's being used more and more every year.
That's very interesting. It's interesting to see how it becomes useful in different ways over time. We have another question, which is, have you ever found evidence using a drone and global mapper processing that would have otherwise been potentially missed?
Yes, happens all the time, particularly with crash scenes, because a lot of the times the marks that we're looking for on the roadway that kind of tell the story of the whole crash many times aren't visible until you actually get the top-down view and are able to kind of follow the marks through the arc of the crash. And so yes, that happens quite a bit.
Very interesting. Thank you. So I have someone else who's wondering, what is the response time of your mapping team? And being police, are you able to get around the need for FAA requirements in airspace with flight height requirements?
That's actually a really good question. The response time, Captain Burke and I are fortunate that the drones that we have are assigned to us. That's been an issue with other departments around us, where the drones, the UAVs, are just at a one location. You have to go get it and then go out. It really increases the response time. But Captain Burke and I are very fortunate that, like I said, they're assigned to us. They're in our cars. So as soon as we get the call, we head out. As far as flight restrictions, we're pretty close to the Portland International Jetport, PWM, which is Class C airspace. Fortunately, most of our deployments are just on the outside of the Class C airspace. But matter of fact, just this morning, I submitted a report for a crash that I did that was in the Class C airspace. We have COAs from the FAA, jurisdictional COAs, for that airspace, for that specific airspace. So that, along with the Portland ATCs, pretty user-friendly. So I've called them probably a dozen times, and it's always a blanket. Yep, as soon as I hear we have a COA, go ahead and fly. And like I said, I just submitted a report this morning for a crash that I did not too long ago. It's really easy. Just call them up, tell them what you want, tell them you got the COA, and the answer so far has always been, yep, go ahead and fly, do what you got to do.
I think we're going to wrap it up after this next question, but I have someone wondering, how long does it take to process the images, and how much time do you save with this workflow?
So when we were using the total station, it would take us anywhere between an hour and 3 hours to collect the data needed for the crash, and then it was another several hours to draw the image on the software. But now with the UAV, we are down to about 20 minutes collecting the data on scene, and whatever Global Mapper has done in the background has greatly improved the processing speed on the computers, because we're down from a couple of hours of processing time. I think that the average now, we're probably half hour, 45 minutes. That seems about the average for processing time. Yeah. So it's really reduced our not only computer time but on scene time.
That's amazing. Well, thank you both so much for joining us for your session and for this Q&A, and I hope that you have a great day, and thank you.
Thank you very much.
Thank you.
Up next, we have a Global Mapper presentation from Gus Cooke. Take it away, Gus.
Hello, everybody. How's it going? Thank you all for taking the time to join us today, talk about various functions and features related to Global Mapper as well as Geographic Calculator. So I'm going to go ahead and share my screen here and talk about a specific use case here. And that use case is going to be performing a suitability analysis for a solar farm using Global Mapper as well as some Global Mapper Pro tools. My name is Gus Cooke. I am a senior application specialist here at Blue Marble Geographics. Hello to everybody that I've had the opportunity to work with all throughout the world. I work on the technical support team here at Blue Marble. So if you've reached out to GeoHelp, which is our technical support inbox, chances are we may have interacted at some point. So this is going to be a two-step process. And what we're going to be doing is utilizing some publicly available data in order to perform this suitability analysis. That publicly available data is going to be some USGS 3DEP digital terrain model, some elevation grid data, as well as a publicly available parcel map and some 3DEP LiDAR data that we're going to also utilize to create a digital surface model. And I'll talk about the difference between those when we get into it. So again, yes, we're using this publicly sourced data. And what we're going to do is use this data to identify the parcels that meet a specific set of site requirements. Now, these site requirements include at least the parcel size being 10 or more acres. Each of these parcels should be within 0.2 miles of a power line. They should optimally be south facing because we're performing this analysis in the northern hemisphere. South facing slopes are generally get a little bit more sun. And then we want to ensure on average a maximum slope of about 5 degrees here. I'm going to go ahead and shut my camera off so we can focus in on our slides here. So this is going to, again, be a two-step process. The first step is going to be locating our potentially suitable locations. Once we've performed that process, this is going to involve connecting to a web map service through our Connect to Online Sources tool, downloading data to store it locally so we can use it in our analysis, then using the vectorized raster tool to take that elevation data and create polygons or area features that represent specific areas of particular slope ranges or slope direction ranges, which I'll talk about as we get into it. Moving on, this is gonna be very vector heavy for this part of the analysis. We're going to use the spatial operations tool. Essentially, spatial operations and spatial operations predicates allow you to identify features within one particular layer based on their kind of relationship to features within a second layer. And we're going to perform a data query to kind of, based on the results of that spatial operation, further narrow down our set of viable parcels. And then lastly, we're going to apply a buffer to our line features representing the locations of our power lines, and then do one more spatial operation to find all of the parcels that are within that 0.2 mile buffer. Once we've gone through all of that, then we're going to move on to a second part of the process, evaluating our candidate locations. And this is going to utilize what I was really excited to talk about today, a new feature that was included within Global Mapper Pro version 26.0, our solar shadow calculations tool. So using some USGS 3DEP LiDAR data, I'm going to generate digital surface models. So a digital surface model, for those of you who might need a refresher or may not be familiar, is going to contain my built structures as well as my vegetation. I want that to be included in my solar analysis. So that's the reason that we're not using the 3DEP elevation grid. That's why we're going to create these new grids that are going to include my trees, include my buildings. So those will affect my analysis. Then we're going to use that as the source data to perform this solar shadow calculation, which is going to create a new raster surface in which the per cell values represent the percent in shade versus in sun. We're going to combine some of those outputs to get kind of a yearly average using our raster calculator tool. And then we're going to actually apply those percent in shade values to my parcel features that I've identified in order to create kind of a nice visualization colored based on that attribute representing my kind of optimal candidate location. So let's jump into the user interface here and talk about how this process works. So initially, I'm going to talk about kind of source data acquisition. Global Mapper allows the connection to a set of built-in online data sources. So that can be a web map service, web map tile service, or anything else that you want to connect to. You can always use one of the built-in sources, or you can add your own source if you have a particular stream data source that you want to connect to. Once I've connected to that, you can see, for example, I've connected to the 3DP elevation grid here. I'm going to just enable. It's being streamed in, but in order to use it for our processing, we want to store it locally. In order to do so, we would just select that layer for export, and then export that to a locally stored file, depending on whatever kind of file format we want to choose. So what I've done, I've already done this process here. I've stored it locally. It's ready to go for use in my analysis. So let's start with identifying out of another one of my source data layers, my parcel layer, which of these parcels is likely going to be the most suitable based on our set of criteria for a solar farm installation. So the first thing that I want to do is extract areas of specific slope ranges from my elevation data. And I'm going to do this utilizing our vectorized raster tool. So I'm going to go up here. It's kind of located here, and we call this the advanced digitizer toolbar. You can see a little pencil drawing a little line there. And I would just select that. But prior to doing so, I'm going to actually switch to our slope shader. So now, because I've switched to our slope shader, when I open up this tool and making sure I'm choosing the correct layer there, it's going to allow me to, rather than extracting a particular range of elevations, if I had a regular elevation shader enabled, it's going to allow me to extract a specific range of slope values. So our target range here is 0 to 5 degrees. And after I ran that, you can see that that's a pretty wide coverage in terms of 0 to 5 degrees. This is there isn't a lot of kind of range and slope in this area. So we're pretty good to go in that aspect there. Moving on, we're going to talk about identifying areas that are within our required slope direction or our orientation of the slope. So we're going to switch from our slope shader to our slope direction shader. And we can see that these degrees no longer represent slope. They represent the orientation of the slope. So we want south facing. South facing is going to be about 250 to 150 degrees. We're going to go back with this slope shader, slope direction shader enabled, go back into vectorized raster. And then we would enter the range of values that we want. So let's say 150 to 250. And I'm going to discard all areas that are smaller than, say, 100 acres here to just get more generalized locations. So we can take a quick look at the output from that. We have a couple of these vector features representing our south-facing slopes. So the first thing I want to do is perform a spatial operations on my parcels and my south-facing slopes, or my larger regions of south-facing slope. And I want to identify all the parcels that intersect with these particular features. So I'm going to open up our spatial operations tool here. And then within spatial operations, I'm going to choose my source or my source data, and then kind of the layer to compare against. So we're going to be identifying all of the parcels that intersect with our south facing areas there. And then for my output, I'm going to create a new layer. And I've already run this for us. So here's our output. I'm going to toggle off my parcels, toggle on just my south facing parcels. And we can see that there's a lot of small ones here that don't meet our 10-acre minimum size criteria. So in order to deal with that, I'm going to query this parcel layer based on a particular attribute, which is the acres attribute. So I'm going to select this search vector data tool. And what this is going to allow me to do is enter a custom query in order to limit this result. Right now we're viewing all of the features within that layer. So what I wanted to do, I didn't mean to close that, with apologies, let me reopen that very quickly, is enter a very simple formula here. So I'm going to add my acres attribute, and we want greater or the same than 10 acres. I'm going to search, and we're going to narrow that list down to just the features that meet that particular criteria. So with those selected, what I did was just Control C and then Control V, and I copied those to a new layer. And you can take a look at that layer that I was able to generate here. And that new layer is our south facing 10 plus acres parcels that we've been able to identify. Now for one more kind of vector analysis part of the process, we want to make sure that the parcels we've identified are within a 0.2 mile boundary from our power line layer. So we have our power lines here. They're kind of hard to see, so I'm going to just temporarily turn off all my kind of base map there. So the first step in this process is going to be to select all the features within that power line layer and then create a buffer feature. And that buffer feature is going to be a 0.2 mile buffer. And we can take a quick look at that buffer that we were generating. And then the next step in that process, I'm not going to show it here because we've already talked about spatial operations, is to go back into spatial operations. I'm going to run another intersect on my parcels, my identified 10 plus acre south facing parcels, and my 0.2 mile boundary around my power lines. So this is going to result in this layer here. These are my identified parcels that meet that specific criteria. And you may note that they have some styling applied to them. And we're going to talk about how we got to have that styling applied. So we're moving on from the first kind of step in the process, which is going to be locating potential sites. Now we're going to evaluate our potential candidate sites. So the first step in this kind of second process here to evaluate these that I performed was obtaining some 3DEP source LiDAR data. So the data that's used to generate this digital elevation model. But we want to obtain that source data in order to create a grid that, again, includes my vegetation and includes my built structures so I can use them in my solar analysis. And I did this on a more localized level. I'm going to switch to just a regular elevation shader there. And those are my two kind of source grids for each of my sites. So what I did was download some LiDAR data from the 3DEP online portal, and then I loaded it in and then used our create elevation grid tool to create these DSMs that I'm going to use. So these are going to be the source data for performing our solar shadow calculations. The solar shadow calculations tool can be found here in the analysis toolbar. So I'm going to just select that tool here. and we can choose which particular layers we're going to run this analysis on. One thing to note, if we have 3D vector data, so any kind of vector data that has elevation values associated with it, we can actually utilize those as obstructions going to affect the output of our sun shade analysis. Now, for a specific, we can do this at a specific time or at a specific range of times and dates. So I'm going to specify my UTC offset. So we're in the northeastern United States for this particular area. So I'm going to do -4 for my UTC offset. And then for my start and stop time and date, I'm going to do the winter solstice first from 2024. So 12/24/2024 at 6 a.m. and we'll go to about 9 o'clock, 9:30 that night, sampling every 5 minutes. We're going to do this at a height of about 5 feet. That's kind of just an estimated height for a solar panel, hypothetically. And our output is going to be a shadow percent grid, where the grid cells represent the percent, or the values of the grid cells rather, represent the percentage of time that that particular cell is in shade. So lower values are going to mean more sun. So we can take a quick look at some of those outputs here, and this is just for example, for December. And what I'm going to actually do is go back and run this again, or let me enable my source layer again. Go back, run this again for a different range of dates. And this time I'm going to do the summer solstice, so June 20th. So I would enter that different range of dates, repeat that process, and now we have these two kind of layers representing both ends of the spectrum in terms of the amount of light per year. We can see that the June one we get a lot more light than the December one for obvious reasons. So we want to combine those into an average. So we're going to do this using our raster calculator tool. We could choose our input layers here, and raster calculator allows us to kind of perform calculations on different input bands, and we can either subtract or multiply the per cell values of those bands to create a new raster output. And essentially what I've done is create two averaged shadow percentage grid files here. Now for a final step in the process, I actually selected my parcel layers or my parcels features here, and I want to visualize these based on kind of the shadow percentage or percent time that it's in shade. So we're going to use a little bit of a workaround here because these shadow percent cell values are represented as elevation. I'm going to just right click analysis measurement and then calculate elevation and slope statistics for that particular feature. Now that feature has a new set of attributes, one of them being an average elevation. So what I did was just change the name of that particular attribute and then colored that particular layer within my vector options, and then colored it as well as labeled it based on that shadow percentage attribute. And so my final output here are those identified vector features representing the parcels that meet our criteria, and they're styled and colored based on the lighter ones being less shade and therefore more suitable for a solar farm installation.
Hi Gus, thank you so much for that presentation.
Absolutely.
All right, so we've got some questions coming in from our attendees. I'm going to get started with that. The first one comes from Peter and is asking the use of the built-in map sources. Are those maps free for commercial use?
That's a great question. So each of our So we are not a data provider. So what we allow access to third-party web map services and other stream data sources. So the terms and conditions, you can right-click on a particular source and allows you to view the particular terms and conditions for that particular source. In this particular demonstration, I was using that USGS 3DP data, which is pretty much open for most, if not all, use cases, but it'll depend on which source you're connecting to.
Awesome. Thank you so much. So we also have another question from someone wondering how to set up the shadow calculations, how to get there and whatnot.
Absolutely. So the solar shadow calculations tool is a Global Mapper Pro feature, it should be noted. So you need to have a Pro license. And it is accessible either from the terrain analysis drop-down menu within, it was added in version 26. So you want to make sure you're at least using that version in order to be able to access it. It's going to be in the terrain analysis drop-down menu, and it's also in the analysis toolbar.
Amazing. Thank you. So another question that we have, it's a bit of a random question, but it does relate. We have someone wondering if you've attempted to script this workflow before.
Yeah, that's a great question. And I'm really glad you brought that up, because you may have noted that part of that workflow was kind of this repetitive process where I needed to kind of repeat the same tool with different parameters. So I was just changing the date and time range and then running it basically 4 times, twice for each site. And there is a global mapper script command for the solar shadow analysis tool. So that is definitely something that would benefit from being automated using global mapper script language, especially for that part of the process. But yeah, generally all of this could be potentially scripted for sure.
Awesome. Thank you so much. We've got someone wondering if there's any training available for custom raster calculation formulas.
That's a great question. So I know that we definitely talk about the raster calculator tool, and specifically with the NDVI analysis is kind of the example within our public classes. I don't think we currently have anything in terms of custom training related to that particular tool, but definitely, the way that I would go about it is reach out to GeoHelp at bluemarblegeo.com, which is our support team, and we will be happy to help you. Whatever your specific use case for that tool might be, will help you get kind of up and going with that as needed.
And then finally, I'm going to ask, why do the shadow percent grids show meters as the unit of measure in the scale bar? And also, as a second part, can we use vector data like 3D building polygons as obstructions when performing solar analysis?
Awesome. Yeah. So two good questions there. The first of which, so you can. It's good to note that although in Global Mapper it's going to treat any kind of it can treat any kind of non-RGB raster. So it's any raster which is just a set of cells, and each of those have a particular value that represents them. It doesn't need to specifically be elevation, but you can load it in, and Global Mapper will treat it like elevation, which allows you to kind of perform different kind of quote unquote elevation specific kind of workflows on that raster data, regardless of what those kind of Z values per cell values represent. And then in terms of the second question, yes, you can use 3D vector features as obstructions within the solar analysis tool.
Amazing. Thank you so much. Well, thank you so much for your presentation, Gus. I'm going to welcome Jess back.
Awesome. Thanks, Meg.
Hello.
Hi, Jess.
Hi. Thank you, everybody, for your presentations and for attending. It's time to announce our giveaway recipients. So Global Mapper Pro is going to be awarded to John Bailey. And then we have Global Mapper going to Adam Campbell. Global Mapper Mobile for Seamus Shee, and Geographic Calculator for Kara Wadu. So congratulations, you'll be hearing from our sales team soon. If for some reason you do not hear from them within the next week, please reach out to us at marketing@bluemarblegeo.com. So thank you everyone for attending GeoTalks 2025. We hope these sessions were valuable to you. You can find us on social media for updates and events. Please sign up for our newsletter to keep updated on Blue Marble Geographics. Thank you again for joining us.
Thanks for joining us. Bye.
Bye.